From the Library of Congress in Washington, D.C.
Now what I'm going to do is turn it over to Kurt for our third session. Thank you again.
Thank you very much, Stacy. Ladies and gentlemen, welcome back. And I do hope that you all had an enjoyable lunch break with opportunities to see old colleagues and get to know new ones. My name is Kurt Helfrich, and I'm an archivist in the National Gallery of Art's Gallery Archives here in Washington, D.C. It is a real pleasure and honor to be able to moderate this session on access use cases. Before I introduce today's speakers, I hope you won't mind a slight digression. Being here today, I am reminded of a comment made by my British colleague Charles Hind at a conference on digital design records I was involved with that was held at the Royal Institute of British Architects in London in 2013. At the end of the conference, Charles challenged us to, in quotes, "Show me the uses by external researchers for these digital files, and I will really begin to understand their value," end quote. Today's speakers are doing just that. Through their presentations, they are helping us to understand how researchers are and will be making use of not just digital files, but data sets. They are also examining the context in which these files are created as a means for us to further understand their potential research value. And now I'd like to briefly introduce today's four speakers. Please note that more extensive biographies of them can be found on the symposium website. So our first presenter today is Andrew Witt, and Andrew is assistant professor in the practice of architecture at the Graduate School of Design, Harvard University. Our second presenter will be Ewan Cochrane, who is the digital preservation manager at Yale University's library. Our third presenter is Matthew Allen, who is a doctoral candidate at Harvard University's Graduate School of Design and teaches at the University of Toronto's John H. Daniels Faculty of Architecture, Landscape, and Design. Our final and fourth speaker is Dennis Sheldon, who is associate professor and director of the Digital Building Laboratory at the Georgia Tech School of Architecture in Atlanta. We are keeping our speakers to a tight 15-minute schedule to allow time following their presentations for questions from the audience. So I'm afraid we're going to be a bit draconian. With that, though, I would like to ask Andrew Witt to come up to the podium and begin his presentation. Thank you very much.
So we heard a lot about structured data in the first half of the day. I'm going to go in exactly the opposite direction and talk about a lot of unstructured data and ways to deal with that, or semi-structured data, I guess I would say. So the expanded intellectual and technical scope of architecture in the 20th and 21st centuries has drawn architects to the use of automation to organize and scale information and work. Automation includes both commercial authoring software and the customized scripts and softwares that designers themselves create. These methods encapsulate or black box domain knowledge to be applied automatically. And I show this image just to mention, like, in a previous life, Dennis and I worked together at Gary Technologies, and I curated this sort of like portion of this massive retrospective at the Pompidou of Frank Gehry's use of technology. And so a lot of my perspective was shaped by sort of like digging through those archives and trying to reassemble what actually went on when those buildings were being put together. So scripting has significantly impacted how design has developed and thus how historians must understand digital documents. So here I'm going to propose three implications of that. First, source code as a historical document. Second, digital forensics. And I realized actually after the first session that I'm using this term forensics in a slightly different way than the sort of technical term of art sense, but we'll get into that. And third, AI archival agents. Ultimately, the possibility is that historians themselves might script their own tools to understand these documents. And at the frontiers of this possibility are the applications of things like sentiment analysis, machine vision, artificial intelligence to crawl archives, and sort of make sense of them at a large scale. So this is a video of a textual analysis of an important theoretical text from the 60s called a pattern language. It applies sentiment analysis ideas to theoretical architectural texts and then compares them to understand who is being sort of the most polemic, the most sort of like unbiased, and the most sort of hyperbolic. So computational processes in design have given rise to new kinds of collateral documents, and one potentially very rich new archive are obviously these scripts and code bases themselves for the applications developed specifically for design projects. The language in which code is written, the organization of its components, the subject domains of the external modules that it draws on, all of these reveal certain proclivities in the way that designers choose to organize technical knowledge. And it suggests how designers themselves might feel about how architectural practice might evolve in the future. So each of them are sort of like putting a stake in the sand about how they think the discipline should evolve. So let's contrast two projects that are actually drawn from the CCA's digital archive, Mark Goldthorpe's Hyposurface and Chuck Hoberman's Iris Dome. So we'll begin with the Iris Dome. So, you know, both of these projects are large, geometrically complex kinematic installations with very sophisticated mechanical systems. Both are composed of hundreds of custom moving parts, and they both relied on extensive scripted automation directed by the designer. But the distinction between the use of scripting and automation is, I think, very revealing. So we'll begin with Hoberman. So Hoberman's archive preserves about 74 distinct scripts developed in the Lisp language of AutoCAD. So, you know, any of you who've been around for a little while, that probably takes you back. These scripts were used to lay out and draw the mechanical components of his complex assemblies, and thus were reused on multiple projects. It became a sort of repository for knowledge reuse. They became a way to automate and parametrically adapt certain aspects of the design. And on the Dome project, Hoberman had about 12 different specific scripts for that project and about 52 drawing files. So as a general rule, maybe like 20% of the design intelligence of the project was embedded in this source code. So Hoberman developed these tools as on a pragmatic and on-demand basis to address very specific problems. So it's really obvious when you're reading through these that he wrote them himself. He didn't really document them extensively. If you know anything about source code, there were very, very few comments. And the way in which they're written is kind of like, it's raw in a way, but it's also very adaptable. They're written in a code style which suggests a specific single author and user and very sort of like targeted and tactical applications. So Mark Goldthorpe's approach to the hyposurface was quite different. It was a single and unique project, a significant monumental project, but a single project nonetheless, and there was no knowledge reuse per se. Instead, there was a need through code to manage a complex collaboration structure. So the project demanded support from a range of unusual consultants, people like mathematicians, mechatronics experts, pneumatics engineers, rubber researchers. So, you know, architects are no strangers to collaboration, but these particular domains were quite, I would say, foreign to typical architecture practice. So the single software application became one of the templates for managing that collaborative knowledge. So there wasn't knowledge reuse per se, and so there was a need to manage these domains. So the software components were developed by Goldthorpe's team members, primarily Xavier Rubatai, who's sort of like listed in this organogram. And instead of a flat list of bespoke scripts, as you have in Hoberman's case, the hyposurface team hierarchically combined componentized libraries into more extensive packages in a single coordinated software. You have a sort of more hierarchical organization, which essentially mirrors the project team structure. So mathematical, mechanical, electrical control, and design parameters all coexisted in this software. It wasn't intended actually to automate the design of the hyposurface, as in Hoberman's case, but instead to automate its control, and in particular the motion of hundreds of linear actuators. So here in this exploded axle, you can see where those linear actuators fall. And what I think is kind of interesting is you have the layers of sort of like electrical control, sort of like this very specific bespoke rubber, the actuators themselves, and the architecture. It kind of like mirrors in a certain way the script organization, actually. Yeah. So Hoberman and Goldthorpe's approaches illustrate two archetypal but different approaches to code. The artisan computational designer, maybe in the case of Hoberman, on the one hand, and the organization builder on the other. One effectively synthesizes that knowledge him or herself, so Hoberman was sort of like a sculptor, an architect, and an engineer. The other uses code as a means of knowledge synthesis. So both are kind of forerunners in a certain way of approaches that we see today. Now, computers are not only geometry producers, but they're also recorders, obviously. So a digitally conceived drawing is, in fact, just an automatic log of transactions. And the operations recorded therein are sometimes atomically stamped with things like time, location, and authorship information. The automatic nature of digital recording can actually be a tool for very interesting forensic reconstruction processes. So a curious quality of these particular kinds of sequences of operations is that they record chronologically not only human authorship, but also the sequence of certain algorithmic processes. So I should mention there's some great work here from Jonah Ross-Myers and Anren Lee, who were involved with this project. So different software generates the same DOM in different ways, leading to distinct and characteristic operational footprints. For example, this diagram compares how different programs log operationally sequences in slightly different ways.
5 minutes. So, yeah.
Really? Okay. Cool. My stopwatch says differently, but maybe. Thanks to the journaled and sequential nature of digital design files, we can reconstruct the chronology of their creation. So with certain formats, I mean, it's very format particular, but this allows us to see step by step how a designer modeled a particular form. It can even allow us to see gaps, erasures, and hesitations. So here we see the timeline of a particular Revit file and the sort of like chronological deconstruction of that file. So at the far right, you see a sort of like linear sequence of how the designer actually modeled that, that file. So we can visualize these sequences as three-dimensional exploded axonometrics, revealing a kind of digital palimpsest and literally see the design process unfold. So this is a matrix of a series of these kind of exploded axos, and it's very, it's revealing in certain cases because you begin to understand, okay, what are the problems that the architects sort of like really labored over? What are the problems which were really sort of like done as a matter of course? And we can begin to interpret priorities in these sort of expanded drawings. So it's so it's possible to track, journal, and visualize authorship in real time, just as so it's possible to do this in real time as well. So just as our eyes track irregular saccadic patterns, designers in this sort of like irregular way also rotate, flip, and work with their models. I'm not sure if this line drawing is coming through, but essentially this is a process of modeling which has tracked the motions of the designer themselves. So you can see how the designer manipulates the models. You can begin to sort of create this kind of like psychometrics of design purely from these logs. Here's another example of that. So briefly, I want to mention maybe a new frontier, which is kind of alluded to in the first session. Advances in techniques from data science and AI allow us to work with these logs and digital files in new ways. So often associated with big data trends or machine learning, they're highly relevant for less structured sets of data. So images that we might have from, as sort of like project collateral, sort of the visual representation of models as opposed to their data representation, we can begin to scan these and use machine vision to classify them in historically interesting ways. So I'll mention an example, not directly archival, but with archival implications. Here we see a machine vision algorithm, or sorry, this is an example of a facade which the way that the human would see it on the left and the way that the machine would see it on the right. And from this network, you can sort of like prioritize certain kinds of operations which extract sort of invariants about what this facade means. And you could use this for very broad classifications of forms. So this example is not directly archival, but it has archival implications. This is a machine vision algorithm crawling a New York City plan and classifying by common plan outline thousands of buildings. And so this is you'll see over time it builds actually like this phylogenetic tree of form just from those morphological characteristics. And what's interesting about this is that, imagine you were to take a museum archive of visual objects or building documents or facade elements or 3D models and ask questions about what are all of the possible precedents for this one object. This is a way to actually do that by scaling up human intuition into a sort of machine platform. And so this is sort of a zoomed out view of 100,000 buildings in central Berlin. So here you see those buildings sort of like clustered by similarity. And as you move back out, you begin to see these kind of like continents of form that emerge from that classification. So, the software draws new charts of the past that allow us to make sense of what we've built holistically and to map all of architecture as it were. We can algorithmically map our cultural heritage comprehensively. So these are just a couple of the ways in which these files considered almost as logs allow us new ways of addressing questions about the design process. So how do designers organize and encapsulate knowledge? How do different designers draw differently? How do designers perceive in the design process? And how does the whole catalog of built form relate holistically? So these examples reveal new possibilities for the use of programmatic information generated by both the designer and the historian to uncover the heuristic and epistemic methods of design. So I think I got it. Thank you.
I'm going to talk about emulation for access. I was asked to talk about a particular use case. I can talk about this more generally, but I'm going to go through a particular use case. This is it. I can't remember exactly when this was, but some months ago, we had a small architecture design archivists meeting and symposium at Yale in the architecture school. And at the time, the Canadian Centre for Architecture and in collaboration with Yale, had an exhibit in the architecture school about archaeology of the digital. And I work with Tim Walsh up at CCA and Susie in the archives at Yale to put together this workstation, in which a user can just click into, and they get a screen, an HTML screen like this, with a list of environments that they can click on. Now, when they click on those, it loads an emulated version of the original environment, the original computer associated with those design records, and they can interact with them using the original software. And I was going to put some screenshots in here, expecting none of this to work, but I think it is kind of working, so I will try and show you what that looks like. The example I just showed in that diagram, in that photo, was all running on a local computer. It's what we call the reading room or exhibit implementation of this software that we're using. But it also runs in a web browser. That's the standard way to access this emulation framework. And I'll talk more about it, but just to show you what it's like. For the end user, whenever they want to interact with something, they get a link, they click on the link, and it loads the environment automatically in the background. So this is Windows 98, as you'll see.
Yeah.
Click the wrong button there.
Where's the paperclip? Show the paperclip.
Let's try that again.
Where's Clippy?
I have Clippy. I can show you Clippy.
Thanks.
Yes, I'm loading it again. But Windows 98, as you saw, it's just a click of a button. It loads up. And what the user gets presented with in this case is a folder full of the files that are relevant to the records that they cared about. Right, so this example is actually from Balmori Associates. We had someone from their talk this morning. It's in the archives at Yale, and if I open this now, it'll open in AutoCAD Release 14, I think. Right, and I can click that, and you see the diagram. And you can just interact with it like you would have using the original software, zoom in and what have you, and it works. Let's see if I have this on here while I'm here. Let's open up Word and see if Clippy runs. Yeah, there he goes. Right. So I'll stop this one, go back to the slides, and start talking about this technology briefly. So emulation as a service is what's being used to power all of this, both the online version you just saw and the one we had on the device in the room, the reading room implementation. It provides remote access to pre-configured virtual computers. that can be accessed with one click. It can be done via a web browser or in a reading room environment. It just requires a web browser. Any modern web browser can access this. And one of the best things about it is it abstracts away all the issues with configuring emulators from the end users and even the staff in archives and libraries and so on, because they can be pre-configured by experts, and the user then just needs to add their content to them. Or the staff member can just add the content, click the button, and it loads in the browser for them. You can also choose to configure these environments so that when an end user does something inside of it, it is either saved or not. And in most cases, we just say, let's not let them save it. They can do anything. They can delete things. They can edit. We don't care, because when the next user goes to it, it'll be exactly the same as it was before. I'll talk a little more about how this configuration happens next. But another key attribute of this is that you can restrict interactivity. So you can make it so that users can't print anything from within the environment. You can make it so that they can't download or copy anything out of the environment. The worst a user could do would be to take a screenshot. And if you restrict this to a reading room, that even becomes less relevant. And all the emulation is run remotely, and the users are actually accessing it via the web browser as kind of a remote desktop tool. So the process I went through to configure that workstation for the reading room was somewhat complicated, and we're doing a lot of work to automate a lot of this away so that other users that want to use this in the future won't have to go through this process, but I'll walk you through it briefly. So what we do is we create a basic environment and then we add layers on top of that. We're actually going a step further than we might need to. We're buying original hardware or getting donations, and then we're making an image of the hard drives and putting those directly into the emulation framework, so that if someone in the future really wanted to validate that the emulation was accurate, they could come and try it out on the original hardware for as long as that hardware is going to be around. So then we load those into our emulation framework. You can see a list here. And then we start getting software to go into those. We image that software. There's a slightly more relevant example that I never actually managed to get working because of a hardware dongle. And we put that software in here. And then we configure that using the online interface. It gets attached as a CD or whatever to the base environment, and you just install the software like you normally would. And then you can click a button, save it, and it saves a new environment with that software installed. And the way it does that, by the way, is it creates a derivative of the original environment, so it only saves the difference between that first master environment and whatever you've added to it. So from a preservation perspective, you don't have the cost of replicating all that data of the base environment every time you make a change to create a derivative. Now that process doesn't always work. For this particular setup, I actually ended up having to install the software in one case on the original computer and continually image the drive as I added more content. The reason being that the emulator for this particular operating system didn't allow us to change disks while it was running. And to install something that was 10 disks, I had to do it on the original computer and then image that computer. So it's not always that straightforward, but we're making progress. And to fix this particular problem, all that actually needs to happen is some developer needs to add that feature to that emulator. We just haven't got there yet. There's some photographs I took. All right. Now for the reading room setup, what we had was just a little Intel Next Unit of Computing NUC computer, which you see in the red box there, which I first tested again with some old hardware plugged into it. And then I got all the software running on it, and I was using more modern hardware to connect to it. And then for the actual exhibit, I connected up what looked like older hardware, but actually in reality, that little computer is back there somewhere. So this was just, that computer on the left there is just completely doing nothing. So you see it in the space there, and there is a little computer sitting back there that people don't see. So that's just a prop, that other computer. All right, so there are a lot of challenges with this. Here's some of them. Actually, I'll show you a few more in a demo, which might be more relevant. 12. Yeah. Here is, oh crap. 1 second. This mouse has a back button on it that I keep accidentally hitting. Right, we'll try this one. This was an absolute pain to configure. It's AutoCAD Release 12 for Microsoft DOS. and just to get it to install was crazy, far too difficult. But now that it's installed, I can add any content to this. I can share that environment with others depending on all the intellectual property challenges. And then they can add their content and use this to access them. It's that easy now that it's configured. So in here, another thing we see is that I'm not very good with the mouse on this. Is it working still? No, I'll just restart that. What you'll see is that when you go to open a file in here, firstly, you need to know that there's a menu up there. And most end users these days have no clue how to use Microsoft DOS software. And would you have known to move the mouse up to the top corner to see that there's a menu so you can go and open a file? Would you know the command to open a file in MS-DOS? That's a challenge. It was certainly a challenge for me, and I just happened to find this. So now I can go through, and you'll see the next issue. If I go into the folder that has the files and open one, I can't find this file, which is, I believe, a font file. So it turns out, after having a look around in here, AutoCAD actually comes with some fonts, so you can just replace the ones that it's looking for with an AutoCAD one. But this is too difficult, right? We can definitely improve on this. Either way, eventually you get in here and, oops. I'll put a Gothic font in. And there you go. There's the file. But those kind of issues, the fact that the object didn't come with fonts, it reflects the kind of things that were discussed this morning about modern design environments where you have multiple dependencies. Then if you don't have them all, you may not get the same thing that you were expecting originally. This has been happening for a very long time, including in Microsoft DOS era. Let's see if I can show you one more thing. This is slightly less relevant, but I'm going to show you because I tweeted about it this morning and it might be of some interest. We have been going through our general collections in the library and imaging all of our CDs and floppy disks, of which we have far too many, thousands, and we're going to start providing access to them via Emulation as a Service. This is the configuration interface you're seeing here. What we're trying to do is make this extremely simple for configuration, and then we're just going to have a link in the catalog for each of them. And this interface now is able to suggest which environments that CD is likely to run on. And the configuring staff member can then just test one of them. Actually, what it does is it scans all the files on the disk. You can see the file formats down on the list here. And it says these file formats probably run on these environments. You might want to try one of those. But this one in particular, the only reason I'm putting it up here is because it happens to have a few design files on it, which I thought were kind of interesting. So as a configuring user, this might be the process you would use if you were a staff member trying to get an environment set up to provide access to some end user to some of your architectural records. You would attach them through the interface here. You could upload them or what have you. And what we should see is that they end up in a CD-ROM drive on here. I could browse that, but I'm just going to double click and open. And in this case, it just runs. And what I would do now if I was configuring this is I would put a link into the start menu, into the startup folder, sorry, so that when the computer starts next time, it'll automatically load to the screen. And then all I do is hit create object environment, put in some metadata, and it'll get saved. And you'll get a link back that you can then provide to any users, put in your catalog and what have you. And that's as easy as it is. It's fairly straightforward. Let's see if there's anything worth looking at on here. And right now we have all sorts of operating systems and environments available pre-configured, but we're going to be adding more and more. So I'll just go back to the slides. So as I've mentioned and shown a few of, there are a lot of challenges getting to the point we did with just the exhibit environment. We had to get all the hardware and the software, configure all the emulators, configure and install all the software on those emulated environments. We had to deal with DRM, including just license keys, but also in the case of Form Z, I wasn't able to get that working because I had a hardware dongle, and I couldn't emulate that at the time. Intellectual property is something that's another whole topic, which I'm sure Brandon and Peter could answer questions about if you have any. And then there are the issues of the end user being able to use the software, which I showed you before with the DOS example, where it's not intuitive anymore, especially to the younger folks who are growing up with touchscreens, for example, or mobile devices, which we are able to emulate a little bit of at the moment. We can do early Android on here, which is quite nice. And then there are, authenticity. So I don't know if I loaded the AutoCAD 2002 environment, but it comes up with a whole lot of pop-ups. And you got questions, should I configure it so that they automatically come up and the user sees what it was like, or should I configure it so they don't come up so it's not as annoying if you just want to get to the content? And then you need to do things like export the environments if you want to use them in a reading room. We're making that easier, so you can configure one in the web environment, export it so you can put it on your stick. By the way, this is all that reading room environment thing runs off of. I can plug this into my laptop and run it off of that. If I want to export one of those environments to go on here, though, we're making that a little bit easier by making it, you can just click a button in the interface. And then configuring that exhibit hardware wasn't entirely straightforward. We had to get the right dongles together to plug in the old hardware and so on. Whoops, I might go back to that. All right, 1 minute, perfect. So we're aiming to make this really, really easy for everybody. We're starting some work soon in collaboration with the Software Preservation Network, which if you have questions about, I'm sure Jessica will be happy to answer, to basically make it so that there are a whole set of pre-configured emulatable computers available to anyone that wants to participate in this network of emulations of service nodes that we're planning on putting together. And so that you can just say, I've got this file, give me the right software to render it, give me the original software, and you'll get that back in the web browser in that original software. Amongst other things, there's a whole number of various things we're going to be doing with this general idea. One of the things we would love to be able to do in the future is guide the user through using the software by adding layers on top of the emulated environments to say, click here to do this, scroll here, and so on. And it's a pretty straightforward thing to do technologically. We just need to get there, and that's going to take a little bit longer. And I mentioned here, fair use for software. There's a project that Brandon and Peter are doing at University of Virginia, which is trying to establish our rights to do this kind of thing from an intellectual property perspective. I think we're moving on to the next person, but I'm happy to answer questions later. That is my hometown of New Plymouth in New Zealand, and the new extension to the art gallery is this metal-looking building in the background, which I think looks amazing. Thank you.
So what I thought I could bring to this particular panel is a discussion of some of the more normal ways that an architectural historian might use a digital archive. So the projects I'll talk about aren't using cutting-edge methods, and they weren't carried out with a lot of resources. I wanted to highlight the typical conditions under which an architectural...
There will be a rebuttal.
Especially, I'm thinking in particular of historians approaching a topic that they aren't even sure they want to commit to sort of working on, and what they maybe might look for in an archive. So I'll discuss 3 projects that have led so far to 3 small exhibitions. The starting point for the first project was Greg Lynn's observation about how software is sometimes visible in images of architectural design. In this case, different software allows users to create different types of lines or curves. My question was, given a bunch of images of design projects from a certain period, can we infer what software was used to make them? Beyond this, can we start to analyze the feedback between software and ways of thinking about architecture? From time I spent in the exhibition department at the Harvard Graduate School of Design, I knew that they had a set of student projects that they collected at the end of every semester. Because these were just quick student projects, the images were not very polished. The evidence of the software hadn't been scrubbed away, so to speak. This collection was not really archived per se. The computing services team had done some work putting the collection in order, but what I had to work with was essentially a pile of about 28,000 JPEGs from about 5,000 projects and an Excel file with all sorts of different metadata. So knowing that the files were there, I suggested an exhibition to the school, and they graciously agreed to give me a wall in the library. I also proposed linking the show to research I was doing on older software. So the show became a dual exhibition on software in the 60s and 70s and software in the recent past. Finally, part of the project was to more properly archive the student work. So the idea was to sort of usher the work into the library, both symbolically and physically. Because I had a hard drive with all the files, access was not particularly difficult. I made a copy of the files, renamed them, and looked at them all with a few different image viewers. I tagged them, sorted them, rearranged them based on visual conventions that I thought that I was interested in and how I might be able to use them in the show. Part of the show was a wash of all of the images, so I wrote a script to shrink them, combine them together, and lay them out in a series of PDF files for printing. Another section had the names of all the students. Oh, so this is the wall. Another section had the names of all the students involved, so I copied and pasted from Excel to InDesign for that. Finally, there was a slideshow that pulled out some of the images and correlated them with little bits of text. I can't use that mouse. Little bits of text that sort of analyze the visual conventions involved. So this slideshow was playing in the library. This is what the exhibition looked like in the end. There was also a little wall with screenshots of current projects that I solicited from students at the school, sort of a live feed of what was happening upstairs in the school. I'll also note that my ambition has been to put this research into a sort of field guide of the visual conventions of architectural software during this period. So I was somewhat rigorous about the sort of what I was looking for in these files. All right, one lesson from this project begins with the observation that it only worked because I had unusually direct access to the files. I could flip through thousands of JPEG files, sort them, tag them. It's hard to imagine doing this without direct access like that. This was similar to digging through physical archives in some ways. In both cases, we're confronted with a pile of stuff which we can pull things out from and put it back as we want very quickly. With digital files, creating this sort of hands-on feeling of manipulation is essential, I think. I'd like to imagine that there's no good reason it can't be made possible to check out an entire archive on an external hard drive, for example. My point here is that historians are usually operating under a severe time crunch, especially when deciding whether to work on a project or not. And if it appears difficult to get a hold of the files, they may choose not to take on the project at all, right? Okay, the second project I'll talk about begins also with a heap of files, but it was a more heterogeneous heap. The occasion for this research was that an architect, Preston Scott Cohen, was given an opportunity to do an exhibition of a major project of his at Tel Aviv Museum of Art. I was asked to help reconstruct part of the design process, and I did some of the preliminary work, and it was installed at Harvard. Reconstructing the design process would seem to be relatively straightforward. The project was designed by a small number of people, and most of them were still around. It was an entirely digital project. A range of models and drawings from the very beginning of the project coexisted in the firm's project archive. So this is sort of a picture of what you would see if you opened that folder on their server. And it existed in more or less the same structure as when it was being worked on. So the organization was ad hoc, let's say, but it was easy to access. I just had to go to the office, plug into the server, make a copy, and I could use it as I wanted. The problem, of course, was that it was not at all clear what were the most important documents. I could gather all the AutoCAD or Rhino files into one place, but it was difficult to know which one contained the important design decisions. Because my research was destined for an exhibition, the architect had some incentive to help, of course. So I sat down with him and went through all of the files, comparing differences and trying to figure out how sort of what changed between the versions and why. So the process involved a lot of comparison of different types of files. We also, in the process, made a bunch of diagrams. And in fact, it was through this process of drawing diagrams that a lot of the important points came out. It sort of jogged their memory. One of the coolest things we found was this little geometrical sketch off to the side of one of the files, which was later sort of moved into the middle of the building and became the sort of focal point of the whole project, as you can see on the left. All right. So it's clear that insider knowledge was key to the exhibition. Without the architect to carefully think through the design process, Pulling out important moments from the files would have been a much more difficult task. One useful archival practice then, and this was mentioned earlier, especially for small firms, would be to ask designers to spend some time after a project is over simply copying and pasting sort of some key files to a separate folder that could serve as sort of reference points later on if you wanted to sort of reconstruct the design process. All right, going through these files, I found a collection of documents. I found that a collection of documents in their original order provides some valuable clues for the historian. A folder structure can tell you a lot. File adjacencies are sometimes meaningful. To make sense of a workflow, having access to files in their original structure is sometimes crucial. Things like scripts or reference images next to original models or drawings can make all the difference in interpreting it. In contemporary modeling practices, the best way to ensure that a model would even open correctly would be to have a sort of snapshot of the whole computer, it seems like. And actually, absent that, it's hard to guarantee that some things would even work at all, right? Well, not yet. I think ultimately that the way to think about design needs to change drastically as we think about digital archives. Sometimes I personally lapse into imagining that design is something an architect does with pencil and paper, and then I go to look for sketches and drawings for evidence of design decisions. But it's clear that with digital design, an architect is usually looking over someone else's shoulder as they're zooming in and out, turning layers on and off, and rotating things to get just the right view. The important thing is not only to look at the right file, but to have the right viewpoint within the file, the right combination of layers, and so on. So digital files have a much greater depth and complexity than drawings on paper. I mean, we all know this. But luckily, historians can approach archives in new ways. We don't have to be respectful of digital files in the same way we are careful about drawings. We can make a copy of everything and move things around, cut out pieces, save as new files, delete things, create our own folder structure, and so on. The more this can be enabled, I think, the better. All right, so the third project that I'll just very briefly discuss builds on the second. As an architecture student, I came to appreciate the impact of software limitations and bugs on design. If you know that a program will crash after you have, let's say, 10,000 of something, you'll try to design with only 9,000 of them. And then once that bug is fixed, you'll go crazy and make like 100,000 of them, right? I know that 10 years ago, students were eagerly installing beta versions of software as soon as it came out to use the latest features. So this final project was an exploration of the relationship between the evolution of software and the evolution of architectural culture, and ultimately, the evolution of architecture itself, let's say. I didn't begin with a traditional archive, but 3 different sources of information. The first was the changelog of Rhinoceros 3D, a popular digital modeling package. I knew the changelog was available in pieces, but I wasn't able to get it directly from McNeil, so I ended up pulling it piece by piece from archive.org, actually. The second source was text and images from forums that showed bugs that architects encountered in Rhino. And for the third, I put a call out to friends and students for anecdotes about what they thought was the most important command in Rhino. So the idea of the show was to fill up a wall with the changelogging and to correlate the anecdotes and the images with it. So this is sort of what it looked like. So again, it was so at certain points you could see in the changelog that a new command would be added to Rhino, and then there would be anecdotes about like how that particular command related to architectural design, right? So it made a good conversation piece, definitely. Let's see, where are we? And it may have gotten some people to think about the link between the sort of behind-the-scenes practices of software design and their own design work. I wanted to show this project here to emphasize the relevance of all this seemingly peripheral stuff to architectural projects. If, as a historian, you're not focusing on finished buildings, a lot of the things in traditional archives simply don't get to the point. For this show, I didn't want drawings or renderings, but screenshots and forum posts. If I'm trying to focus on some aspect of architectural culture, archival work becomes something like anthropological fieldwork. Part of the job is to scout out possible archives. So in this case, if I care about the impact of software on architecture, it makes me wonder if we should be thinking of archiving not only old versions of software, but things like change logs and tech support forums, for example. The ambitious question to ask here, it seems to me, is how would we archive digital culture? One project I'm working on right now is to collect snapshots of entire computers and to save them as sort of time capsules that capture not only specific projects, but an entire way of working, right? These may or may not be interesting a couple decades from now as kind of case studies. We'll see. I'll end by noting a commonality between the projects I showed. My own privileged position with direct access to files and the people who created them. My sort of final question here is, how can we set up archives that recreate as much as possible this privileged position for every researcher approaching an archive? How can we allow a feeling of direct access or of a window onto a culture? I suspect that this would require a very particular type of archive that we don't actually see very often. Okay, thank you.
Okay, so I think this is going to be a good wrap-up. I'm going to try to connect, actually it turns out I'm going to try to connect some of the themes from this morning around interoperability and IFC and all that kind of BIM, I guess BIM stuff, with some of the themes from this afternoon, including some systems that normal humans use, and some of the stuff that Andrew talked about, but not as smart. So just very briefly, yeah, about me and the lab. As Andrew mentioned, so before I joined Georgia Tech, I was associated with Frank Gehry's office as the technology director and then the CTO of Gehry Technologies. We produced a bunch of different software. I'll talk about one piece of it, and then in parallel, I've been in academia, both at MIT and Georgia Tech and other places. And the lab definitely focuses on things like data standards and interoperability. Also this kind of general, I think project delivery systems may have come up, but how you connect tools, organizations, data, work, and all that kind of stuff, and then some automation stuff, and life goes on. So I'm actually going to talk about 4 use cases. 2 of them, I'm not going to talk about BIM, IFC, and open data standards because I was told that we had that subject covered. I'm going to talk about 2 data systems. One which was actually Andrew's brainchild back in Gehry Technologies. Another system which is a GS8 project that some of the audience may know better than me, Quartz Web, which is about sort of archiving design intent of different courthouses. And then 2 things that are more about sort of the language of design and if we can do stuff to capture that as well. So without further ado, this is the first project that I mentioned. This is a system that was developed actually originally by Andrew when he was working on the Louis Vuitton project in Paris. And the notion there, I think people talked about CATIA, I won't mention that too much, but this idea that you have to manage, with that system you have to manage tens of thousands of files that are evolving asynchronously by different stakeholders across the world, and sort of managing versioning of that and who did what, and sort of just dealing with that sort of evolving asynchronous compound document problem. So, so the system was originally conceived of as sort of wrapping this set of files. Let's see, can I point with anything? But making those, exposing those visually on the web. This was pretty early in the web. It wasn't that early, but not everything was on the web then. But more importantly, kind of capturing the social transactions that happen between different players as these models evolve asynchronously over time. So this is just a kind of an early screenshot, of the kind of what we call the feed of different people working on different components. You could click through it and you'd see the files. This became a kind of a more robust system, which became a commercial product called G-Team. I think I'm on auto. Yeah, okay, we'll just let it run. Okay, which included, again, this idea of kind of the Facebook wall of the project, who did what when. You could drill into that. You had a file structure as well because we needed that. You could get the data on those models, and then you could pull up the kind of the the organization of those files, and it was very sort of tree structured. It's kind of a light version of IFC, which is tree structured as opposed to this big complex hairball of relationships. But it did sort of wrap all these different files in the sort of social transactions among players. And I think that's an important piece for, at least to consider when you're archiving a project, is the fact that these transactions are no longer happening in this super rigid kind of hierarchical structure that we associate with project contracts and delivery, but there's actually sort of cross-pollination happening. It's more of a web of transactions than it is like a hierarchy. So it was kind of, handled both of those in a kind of an early fashion. And just to kind of close the loop, yeah, we sort of started looking at this actually is something you could embed in social media as well. So you could take the model and edit a state and plug it into Facebook and share it with your friends. So that was kind of the beginning of at least. And I guess I should say that as the system evolved, you could upload files in native formats. You could actually download them in IFC, and it stored it in its own file format, its own data format. You could connect different objects to their associated objects. Like so, here you have a view that's tied to a drawing, those kind of things. So these abilities to kind of tie model objects and transactions and different digital assets, I think this is becoming possible now. This became a commercial product or got bought by Trimble, and now it's known as Trimble Connect, and it's moved on beyond that. And there are certainly other systems that do this as well. So, so that's a little bit kind of back to where we were this morning. I wanted to point out another project which isn't, I've had nothing to do with, but it is done by the people in the program at Georgia Tech. And it's a project for the GSA called Quartz Web. That's the link, but you can just Google Quartz Web. Does anybody from the GSA know about this project? Okay. Good, so I can make stuff up. But essentially what this is an online database of about 30 or 40 different courthouses that have metadata associated with those courthouses, images, data associated with where it is, who was the architect, all that kind of good stuff, and some analyses that I think are the most interesting things. So you can do comparisons, pick a couple different courthouses, and see them together. It has things like the drawings and the 3D models, but also figure background kind of views, different analyses, images, of course, and then maybe most interestingly as a segue. 3D models that talk about the different circulation paths. So from what I understand, you guys may know better than me, but courthouses have a very sort of, mission critical idea about which different constituencies, basically the judiciary goes one way, the public goes another way, the indicted go a different way, and you have to keep them separate. And in a three-space configuration, that's actually fairly challenging, and it's challenging to understand too. So, so this system is, I think, complementary to some of the design guidelines that would be associated with courthouses, and sort of prevent an archive of some of the critical things that are in that guideline and that the GSA and the court systems care about for those buildings. So it's seen as a kind of a database and archive of, again, different features of those different projects that you can compare. So those are the two kind of portal views of this kind of digital archiving. And then from there, I want to quickly go to some of the more rarefied stuff around design language. So I thought this was an original thought when I came up with this slide. But on the left, okay, so on the left, obviously, the Rosetta Stone. In the middle, Andrew talked about Christopher Alexander and pattern language. On the right, the court stuff, which isn't mine either. And I think the point is, the point I wanted to make about the Rosetta Stone is, I guess, are there any linguists in the audience? Okay, mostly architects. So obviously, the purpose of an object like the Rosetta Stone isn't just to archive itself. It's to serve as an archive for all possible, languages, what do we want to say, sort of sentences or configurations associated with those languages, right? That's why it's so important. So the question that I think I would pose, and I think Andrew did this a little bit as well, is can we not just, archive a specific object, maybe its BIM representation, but get a little bit deeper in terms of, as he said, the forensics of understanding the DNA of that particular typology, right? So what do all GSA courthouses have in common? How could you compare them to each other? Is there a way of sort of qualifying or quantifying those features, right? So there is some really interesting research work that is really about, I'll just cut forward, is about sort of understanding the languages of design. It goes by a special term called shape grammars. Some of you may have heard of this, but it really is sort of a direct descendant of computational linguistics. And I guess I would just compare these two, because this is worth digging into a little bit. I learned the diagram on the left when I was in high school. That probably dates me. I didn't learn it. The English teacher brought that up one afternoon. Nobody could figure out what he was talking about, and he dropped it. And I imagine a lot of you have the similar experience. So Noam Chomsky, known for a lot of important work, but came up with this epiphany that really all sentences are structured as these binary decompositions. So a sentence can be decomposed into its noun phrase and its verb phrase, the verb phrase in terms of a verb and a noun, a participle, I think. You guys might know better than me. And they sort of cascade down, right? There's this substitution from a high-level object and its decomposition into richer and richer sort of substructures, right? So if you tee it up that way, the idea that there might be some sort of way of decomposing a project into its constituent components and then further, and understanding that structure as you go, makes some sort of sense, and that's really the basis of the shape language, shape grammar canon, if you will. So left and right are two examples. I'll show you. Very good. Okay. Let me see. Let me go to a specific. Well, here's the theory, which is that it's about, again, these substitutions. Every shape, every building, every project can be decomposed into replacement rules that architects might replace one thing with another. I see a square, I rotate it, blah, blah, blah. I can find that shape in my design. I can do that replacement. And so a lot of the work about documenting, this has been done with Frank Lloyd Wright projects and Palladian villas, and the list goes on, but you can essentially sort of archive that set of rules and use it to play back for all kinds of different projects of that typology. So here's some work that ties directly into the Quartz Web project, which is looking at Mies courthouses. As far as I understand, there's quite a few of them. On the left are the original sketches from Mies. On the right are those generated typologies. And those are generated by this list of these substitution rules that you can apply to take the overall courthouse, maybe split it up into, Lord knows, the public and the private, and then down to other refinements. So even down to things like, actual construction typologies, right? So here's again that set of rules being applied, and the fact that you can apply it to a whole bunch of different possible configurations of this Mies courthouse. Last thing I'll show you is some work that actually is just part of what I teach to all the students at Georgia Tech. And it's a little bit the same idea, and it's using Grasshopper, which I think many of you will know is a sort of visual scripting add-on to Rhino. How many of you have heard of Grasshopper? Okay, and it's a very easy way to do some of the crazy stuff that Andrew was talking about. So basically, you can generate scripts by dragging and dropping these blocks. And then you make modifications to the blocks, and it generates these forms. But I think for me, what's interesting, and for what I try to force the students to believe, is that you can actually use that as a diagramming tool in of itself for the organization of the logic of these different projects. And we do a number of case studies of historical projects using these frameworks. And there's a kind of a high-level hypothesis that we actually that I brought from Gary's work, which says, and this may sound crazy or really dumbing it down, but all projects can be decomposed into 3 high-level systems: the exterior volume of it, the floor, top of floor planes, top of slab planes, and the structural grid. And once you have those three canonical systems, you mix and match them, and then you get the sort of the frames that the mullions go in, you know, the core goes in, you know, those kind of things. So there is this kind of natural hierarchy of all projects of that decomposition, and just we actually can look at some core templates and how those things play out. But we look at different sort of typologies, towers, grids, stadium, stations. We actually give out these little templates, and then the students can kind of mix and match those component systems to sort of plug and play different configurations. And here's an example of what an undergraduate team did, the Beijing Stadium. Turns out, you know, it's a great project because it looks like a hairball, but it's a very rational, top-down hierarchical system of this ellipse with the oculus, the ribs that connect those, and then that produces a set of configurations that these different subsystems can go into. And then, so again, we're using on the bottom the program as the map, and that allows you to kind of also decompose the project into its constituent systems. And then, of course, you can do kind of generative reconfiguration of that stuff. So I think that's it. Thanks. That's pretty awesome.
All right, so now we'd like to be able to have questions from the audience. Oh, come on, no, oh, okay.
On the emulation, how far back can you go? Can you go back to green screens and VMS and?
So the way the emulation as a service framework works, is it brings together a bunch of emulators. We just added another one recently. I think they also added the Amiga emulator last year. If there's an emulator for it, we can add it to the network, and I believe there are emulators for a lot of the earlier machines. We haven't added them because we haven't had any use cases yet, but as soon as there is, we can get the developers to integrate them.
What about the systems that had very different display systems or very different input devices?
The display systems are always going to be a challenge, and one of the things we're looking at from a research perspective, or actually I should say the University of Freiburg, who developed the emulation as a service framework, are looking at is how to access the desktop environments from mobile devices, which is where so many people access things these days. There may just be no way to properly map old displays to modern hardware. One of the things that I'm interested in is accessing these kind of things in virtual reality environments, because you can simulate whatever kind of interface you wanted in virtual reality. And I have seen someone did that. They made a virtual reality environment with an emulator backing a computer sitting inside of it. So you could use the original computer in the virtual environment. The original hardware was simulated. It was really cool. And in input devices, what they can do is they can translate any input to any equivalent that is available in the emulator theoretically, and they've done it in practice. They've done it for video cameras and other sensors that we use for digital artworks. So they've connected those to the emulated version of the hardware when the original computer that was in this digital artwork installation died. So they connected it to the new computer which was running the emulation, and they translated the sensor, be it a camera or like a motion sensor, I think was one of them, to the emulated environment, and it accepted it and used that input directly. So if there's a way to translate it to something that means anything to the emulator, then it's all just coding. It just depends on how much time and money you want to put into it.
Hi, Ryan Donaldson with the Durst organization. It's great to hear in these examples of really being able to bring to light architectural practices to be able to make them more engaging. And my question touches on kind of the response to these projects, and in particular, the emulation and exhibitions that were done. In terms of the emulation piece, is there any kind of measuring in terms of almost the performance that's going on in terms of user experience, being able to see what they're going to and being able to then inform further work that you're doing? And on the exhibition side, in terms of visitors and visitor responses and metrics around that, was that something that was a part of the project as well?
I mean, short answer, no. But it's something we've talked about, and we could add monitoring of, say, where users click. And in fact, for a while there, they had an implementation of this that was used for doing bulk migration between formats, where you'd run a migration on one file, and it would copy your interactions with the virtual computer, and you could just replay that over thousands of files to migrate them using the original software. And so the technology's there. If we wanted to monitor everyone interacting with these things, we could. And we didn't monitor the use of the machines in any way in the exhibition.
I mean, I'll just say that also, no. Unfortunately, especially the last exhibition I showed was, meant to be sort of embedded within the community that sort of that the work was showing, and there, maybe not, let's say, surveys or something like that, but some way of creating feedback, sort of interactive displays, or putting up your own post-it notes, or some more sophisticated version of that. Yeah, if I were to do a bigger version of the project, that would be exactly the direction I'd go with it.
Jeffrey Ollett, Vectorworks and Building Smart International. So it goes back to the emulation, and you sort of threw it out, or threw it off. The problem you face when you have applications that use hardware keys for protection, and how difficult then that becomes to then provide emulation and continuity.
There are at least two organizations, I believe, Peter and Brandon, representing one of them, that are looking at whether we could get a DMCA exemption for breaking DRM.
Okay.
There are ways to do it. Whether we're legally allowed to do it or not is another question. You can emulate the dongles and attach them to the virtual serial port or whatever.
Right. So really, it's more of a legal issue. Okay.
But for the most part, it's still hard to emulate them. Someone has to do that for every single one, and that's work. But once you've done it once, it can be, that software can then be used millions of times.
Hi, Eliza again from Sasaki. My question, I have two, so I'll start with Dennis, is about the space, or sorry, the actual word you use was?
Shape grammar, I think.
Shape grammar, yes, exactly, thank you. And the whole concept of visual literacy that goes into that, I think is really important, because from someone who doesn't have an architecture background, which is not always the case, but is often for archivists who are going to be taking care of these things afterwards, there has to be some way for us to be better educated in order to be able to take on this next phase, I think, because a lot of the, rose-tinted glasses and appreciation of the paper-based drawings, you can just say, these are beautiful, I understand, I grasp why this is important, and that's lost often when you're looking at a black screen with a bunch of neon-colored lines. And so I'm wondering, how do we prepare ourselves for that? And if you think the space grammar is the way to go, or if there's something else. And I open that to everyone because they're all researchers.
Well, let me start, because I think there's quite a bit of answer to that. I mean, I'm not sure. I think it's a do you need to know linguistics to be good at language? No. Are most people good linguists? Probably not, even if they're good at language. I think it's a useful technique. I think it is very germane to the historical forensics and understanding of past decision making. It seems like what am I struggling for? It seems like it may not just be sort of an abstract computational technique. It might actually be something that is, could be seen as being human. There's certainly the people that work on it believe that it is, that it's part of the process of design to recognize things and replace them. And that it is, I think I'm certainly part of a group that thinks that, I'm a structuralist, so I believe that the structure of language conditions what we do as whoever we are. So, but it's certainly only one technique for kind of discovering features of and retroactively understanding designs.
Well, with that, I'm afraid we've run out of time. So thank you very much to our panelists. I think we've given excellent presentations. And as well, I'd like to acknowledge Grace, our timekeeper, who's kept us on track. And at this point, we'll take a short break and come back, I think, for 3.
Yes, sure. We'll come back at 3. As we start off and wrap up today, I did want you to please Stick around because we are going to have a summary by Tim Walsh to wrap us up, and then also Kate will be back to make comments. But let me kick it off now for our fourth session, please. Thank you so much.
Okay, hi everybody. What a great day we're having. Wow. I love the energy of having to quiet everyone down because there's so much to say and so many great people to say it with. So thanks everyone for a great day so far. I'm Kit Arrington, work in the Prints and Photographs Division here at the Library of Congress, the home for the ADE Center. I started here in 1995 and cut my teeth, and I'm continuing to work very hard today on the Historic American Building Survey, Historic American Engineering Record, Historic American Landscape Survey, fabulous collections that started in 1933. All of the access and styles and sociology and history, these collections are used constantly this way today, and people are downloading the images and the drawings and making 3D models. Like, it's an alive collection. It's becoming more digital every day, and we hope to continue to be able to provide access to it in those new ways. We've got the heroes, that's what I'm thinking of what this panel is. We've had a lot of really interesting challenges that have been faced and described, and what these guys are doing is the hard work of trying to provide some of those answers and solutions of software and standards. So we're going to be hearing from Phil Roche, yet again, wonderfully, from the CACS Implementers Forum, Jessica Meyerson, Software Preservation Network, SPIN, I think is how it's pronounced. Jeff Willett is going to be talking about smart building and give us some BIM and IFC information. And Roger Grant from the NIBS is going to be introducing some standards information for us. So welcome, and let's get started.
Well, as you know, earlier I was kind of filling in for Rick Zaray of Boeing. And unfortunately, that's not the first time I've done that. But anyway, I'm going to talk about something that's a bit nearer and dearer to my heart, which is interoperability testing. And, you know, that word interoperability has become very common, I think, in the last 5 or 10 years. But I think it was the community that I run in where it came from. But I'm taking credit for it anyway. Okay? You started to see translation software built upon the STEP standard or based upon the STEP standard probably in the 90s, the early 90s. And actually, big OEM companies like the Boeings of the world would actually develop their own translation capability for their CAD system. And then finally you started to see the actual software companies developing this translation capability. But none of them worked very well together. And the STEP standard was, supposed to be, straightforward and unambiguous and all these kinds of things. But these systems didn't interoperate at all. So, and actually I think I'd said this a little earlier, but myself and some other folks in this industry got together and we said, well, how can we test this software? We didn't like those words like compliant and conformant and things like that, because I think if you look out in the general software industry, there are certainly examples of software that's conformant or compliant, but not interoperable at all. So interoperability was our number one goal in starting the CACS Implementer Forum. There's currently 3 hosting organizations of it. The organization that I'm on contract to is called PDES Incorporated. It's primarily a aerospace and defense consortium. ProStep is a project under PDES Inc. ProStep IVIP is, I would call them a German automotive consortium, but they probably prefer to be called a European automotive consortium, heavy German influence. And then AFNet, and don't ask me what that stands for, and it's probably French anyway, but they're kind of a trains, planes, and automobile industry group of France. But those are the organizations that host us The group is composed of computer-aided design and computer-aided engineering vendors, and also what we call third-party vendors, which are the translation software vendors. A third-party vendor doesn't have any authoring software. They just, change the gender of a native file to a neutral file or something like that. It is a closed group. We call it a sandbox. We do not release results of a particular vendor to the world or to our member organizations. The only results they see are kind of rolled up, so how well did we do on geometric accuracy or something like that. And so it is a trusted environment. And I don't think you see this much in other software development groups, but you'll actually see somebody from, I'm just going to make this up, Dassault Systems helping out somebody from Siemens NX or SolidWorks or whatever, and it's kind of a neat environment. We launched this in '99. That was kind of part of the history lessons. We've actually done 40 rounds of testing on the CAD side, and we're just starting on the CAE side. And really our primary mission is to meet industry's needs by providing them with these interoperable products. Already said we test in a closed environment. We don't let any specific results out. All the participants are testing alpha and beta software. It's pre-production. So this early detection of errors in their software actually provides them with a faster development cycle. One other thing that I think is a big benefit of this is that we actually test the standard as it's being developed. And you'll see a chart a little later. But the current step standard we're working on is AP242. And it was as soon as we had a data model of AP242, we started testing it. And yet it's going through the ISO ballot process at the same time, so it's not even an international standard yet. So we tested the standard while it was being developed. We provided impact to them, or input back to them, so that they could improve the standard and get rid of the bugs in it. We call this CACSI up on a page, but up in the upper left there we have the user companies, and they're a broad range of types of companies. They're aerospace and defense, they're automotive, shipbuilding, you name it. But they kind of provide us with their requirements, and relatively recent requirement is that we have to have geometric and dimensional tolerances in the step-based products. So, we go off and see how hard that's going to be to do, and see if it's in the data model, the group down there in the lower left, the ISO. And then we also get test models from the user companies to do our testing with, and we go off and test it. And so the user companies get interoperable software back. The standards groups, they get standardization issues fed back to them. And just to the general world over there on the bottom right, they get commercial products that work. So I'm not going to spend any time on this. This is kind of the scope of AP242, but it's all those kinds of things, that they use in a mechanical design context. And an important word there is managed model-based 3D engineering. So, it's designed to be managed by a PDM or a PLM system. It has all the data necessary to do that. And like I said, this is the kind of the history of AP242 and testing it, if you will. And I think I said we were on the 40th round of testing, but the development of AP242 started at the end of 2010. And along the left-hand side there, those are all the various ISO ballot steps you have to go through. And so we've been testing it all the way along, and actually sometimes we've actually been ahead of the standard, and we'll see things that aren't in the standard, and we'll just make up a data model and stick it into the main data model ourselves and go ahead and test it and then feed that back to the standards folks. Regarding our methodology, the STEP standard uses both Express and XML schemas. XML is primarily used for what I kind of consider the softer stuff, the metadata and the part number, stuff like that. And then we use the Express is primarily used for the geometry and the complex stuff, because Express is a lot more richer modeling language. We also provide these documents called recommended practices documents, and it's kind of a cookbook approach on how you implement the STEP standards. And as I said earlier, these standards were supposed to have been unambiguous, but there's obviously they weren't. And there's a lot of times in the standard where there's multiple paths you can take, or you don't really know what kind of value is expected or something of that nature. So we write these recommended practices documents based upon discussion we have with all the software developers, and it's an agreement, if you will. And then the test case definitions. When the vendor produces a STEP file based upon a particular functionality, we test it for syntax. So is it conformant to the schema? And that's kind of as far as conformance testing goes, just is it conformant to the schema? But we also test it for structure and semantics. And we kind of consider that to be conformant to our, and I don't like even use that word conformance, but applicable, or it lends itself, or it follows along with the recommended practices documents. And actually we get a lot of, I think the IFC and BIM folks have had a lot of interaction with the NIST folks over the years, and kind of the same help, if you will. So, and NIST helps us out with this. Anyway, so these STEP files are submitted, and they're found to be good, and all the other participants post-process them. And we actually have an online system for the participants to go on, and they enter in data about the exchange that they just did, whether they're the native or the target system, and the system does an automatic comparison and shows you where issues are and things like that. It's basically an Excel spreadsheet on steroids. And then a lot of times we find issues during the testing, they're actually resolved before the end of that particular round of testing. The recommended practices documents I mentioned, there's one on how to do business object model assembly structure, geometric and assembly validation properties, and external references. We provide a test case specification at the beginning of every round of testing. Typically, there's a number of test cases in a test suite. A test suite is the overall document. There's a number of test cases in it, and sometimes it has modeling instructions, and it always talks about what statistics are needed by the statistics system we use. There's just a screenshot of our statistics system. Like I said, it's like a spreadsheet on steroids. There's a lot of other things going on in the STEP and the AB 242 realm. NIST has a MBE validation project going on that we kind of feed on. They also have a STEP file analyzer that we use and also provide feedback to, so they can improve that. Besides our own implementer forum, there's also 2 other implementer forums that are kind of in the same realm, and there's a lot of cross-pollination between them. There's the JT implementer forum. JT is a...
Phil, could you step forward to the mic, please? Thanks. I'm sorry.
JT is kind of a semi-proprietary visualization format from Siemens, but they also use the STEP data model as the underlying structure for like assembly structure and the metadata and stuff like that. So we meet with them on a relatively regular basis. And also there's a PDM implementer forum, but it's the PDM systems implementing the STEP standard. And that's it.
Hello, everyone. Hello. Again, my name is, my name is Jessica Meyerson. I was a digital archivist at the University of Texas at Austin for 5 years before taking my current position with Educopia Institute. And there I conduct applied research that advances understanding of digital preservation and scholarly communication landscapes. And I proudly serve the members of the Software Preservation Network, and it is in that capacity that I get to join you here today. And before I begin, allow me to express mine and all SPIN participants and collaborators' thank you to the Library of Congress and the tremendous work of the Organizing and Programming Committee for today's summit. Sincerest thanks to all of the staff that have made this event meaningful for the attendees, and thanks to all of you for attending. We're grateful for the opportunity to be in dialogue with you today, and I want to recognize Matthew Allen for introducing me to the work of Andrew Kovacs. All of the images that I use today in the slides are from Kovac's Archive of the Affinities, which I highly recommend. There are citations for each of the Tumblr citations for each of the images included in the slides. Okay, the first part of my presentation is the case for software as infrastructure. So, well, sneak preview. So Susan Lee Starr, who is an information infrastructure scholar, sadly is no longer with us, wrote in a paper called The Ethnography of Infrastructure, quote, "People commonly envision infrastructure as a system of substrates. It is by definition invisible. It's part of the background for other kinds of work," end quote. Infrastructure is a fundamentally relational concept. The cook considers the water system as working infrastructure integral to making dinner, while for the city planner, it's a variable in a complex planning process or a target for repair. Starr and her colleague completed a study in the early 1990s on an online community called Worm and concluded that infrastructure has several key characteristics, so this is their model. And I'm going to present the case that software has all of these characteristics, with examples where appropriate from architectural design and engineering scholar practitioners, as well as much broader examples provided by the co-founder of Netscape, Mark Anderson, in his 2011 article, Software is Eating the World. The examples still hold true, and frankly, even more so. So software is embedded. It's sunk into and inside of other structures, social arrangements, and technologies. Anderson writes, more and more major businesses and industries are being run on software delivered as online services, from movies to agriculture to national defense to global finance. Matthew Allen, I'll just keep doing that, reviewing an exhibit entitled Architecture, Architectural, and Architecture with a capital A, describes, as evidenced by the works included in the exhibit, how software is not a part of a specific workflow or phase of architectural design, but rather that it's embedded into a creative work routine. Software is transparent, and specifically in this context, meaning that it doesn't have to be reassembled or reinvented each time or for each task, but that it invisibly supports those tasks. Anderson writes, on the back end, software programming tools and internet-based services make it easy to launch new global software-powered startups in many industries without the need to invest in new infrastructure and train new employees. Software has reach and scope beyond a single event or a one-site practice. Anderson writes, software is also eating much of the value chain of industries that are widely viewed as primarily existing in the physical world. Software runs engines, it controls safety features, it guides drivers to destinations, it powers logistics and distribution capabilities of FedEx, Walmart, and the like. As is evidenced by discussions here today, the built environment often begins in a software environment. Software is learned as part of a membership. So similar to the art of drafting, specific planning documentation for the built environment, and different forms of modeling, certain types of software or specific uses of that software are part of the repertoire of a profession or a community of practice. Software is the embodiment of standards. So speaking to Katie's analysis in her dissertation of architectural practice as a socio-technical system, a practice has specific needs and standardized workflows or business rules, some of which can be translated into the functional requirements of software applications. These applications, as embodiments of standards and conventions, have their own impacts on the daily practice as they are adopted and adapted. The use and reuse of these software and resulting digital objects may shape the need or demand for changes or enhancements to the software in the future. Software is built on an installed base. All new infrastructure wrestles with the inertia of the installed base. Software is always wrestling with existing practices, user expectations, and tools. Software is fixed in modular increments, not all at once or globally. Because software exists in a universe of dependencies, you're always pursuing a fix that is the most well-contained, or most loosely coupled to everything else. The fix for the Windows XP users during the WannaCry ransomware event in May 2017 was a patch, not a comprehensive upgrade for those users from XP to Windows 10. What is the smallest change we can make that will repair the system or bring it back into an operational state? Because of this, software is in a state of ongoing repair. And then finally, software becomes visible on breakdown, and this is what we'll problematize. And I don't know if you can see it, but the infrastructure is showing in that photograph. It got cut off a little bit. Your infrastructure is showing. So software can break. It has bugs. But breakdown doesn't map as well as the others because software is so embedded, so to use Anderson's words, consumptive of all structures and industries that we can't decouple the software from other substrates in the system, including users, the network, the regulatory framework, and the industry. I argue that what we mean by software breakdown in today's context is much bigger than that. It's better understood as the access breakdown, or the inability to support meaningful access to digital information. This could be reproducible science and social scientific research, or as Mackenzie Smith wrote in her 2012 article for AIA Online, quote, the need to refer to an old design, consult a change order or ASI from a completed project, or consider an addition to an old building, end quote. The access breakdown reveals or makes visible that social structures and practices in which the software is embedded. I'll repeat that. The access breakdown reveals or makes visible the social structures and practices in which software is embedded. The access breakdown is a comprehensive breakdown of social structures to support information access, communication, legal systems, and the market. And when these social structures break down, they produce and necessitate system-level change. So a little bit more about the access breakdown. Our cultural record is increasingly made up of complex digital objects, as evidenced by discussions here today, which are coupled to software both proprietary and non-proprietary. And I really wish that I could go into this software preservation history, but this is a timeline that's complementary to all of the amazing work that Eliza and Tim and Katie shared with you earlier today that looks at the history of the just the software preservation discourse and just in information science, computing history, and archives. Our culture is increasingly made up of complex digital objects, or what Peterson, Trudy Huskamp Peterson, to be exact, termed, quote, software dependent in 1985. Evidenced by the 30-plus year discourse in information studies, history of computing, and cultural memory preservation alone, and that's not to say there aren't other discursive communities talking about this for a long time, the access breakdown, like most infrastructure breakdowns, is relatively to software slow in the making. So the access breakdown necessitates system-level change that acknowledges software as infrastructure. System-level change. So in 1995, Liam Bannon published a short piece in ACM called The Politics of Design. Quote, the development of computer-based applications requires the collaboration or involvement of a variety of distinctive communities, workers with different skills using different representational frameworks. This poses a number of problems which can't be removed by simply ensuring good communication. He argues it's more fundamental than that. It arises out of different practices of the groups. So how to construct a shared or common information space among these groups is seen as a central concern. Collective impact is a model for understanding system-level change. Collective impact has 5 distinct components. The common agenda, so engaging all of the stakeholders around a problem area and helping them to come to an agreement upon a common vision or goal for change. Shared measurement and data that helps each group determine what specific incremental steps it can take to continue forward progress at the system level. Mutually reinforcing activities that meet the vested interests and economic drivers of each stakeholder group and the system itself. Constant communication and refining of goals of the stakeholders, both individually and as a system. And a lightweight backbone comprising focused facilitators providing the necessary connection work. The Software Preservation Network is building capacity to serve as a lightweight backbone organization that embodies and supports a collective impact approach to software preservation. SPIN was first discussed in a public forum in 2014 as an idea that was conceptualized as a logical extension of the work spanning that roughly 30+ years that had come before, including the Preserving EXE Summit hosted at the LOC in 2013. SPIN believes that software is important to preserve because it is information in and of itself, as well as a dependency to access other digital objects. So the common agenda or mission that unites SPIN's participants and supporters is to preserve software through community engagement, infrastructure support, and knowledge generation. SPIN defined software preservation at the network level as basically 5 core activity areas necessary for successful software preservation. So the first of these is research. So the research working group in SPIN is currently creating a toolkit that people can use to gather data about software preservation and curation, upstream, downstream, that's all in scope here, in their local communities. These shared measurements and associated data establish an understanding of the problem space as it shifts over time. The training and education group is working on 2 major initiatives, the translation of their peer working group's findings into educational materials, as well as a series of software curation recommendations and guidelines for data curators and data management professionals. The metadata and standards group sent out a survey earlier this year to provide a baseline of metadata being used to describe and manage the preservation of and access to software. And based on those findings, even in institutions that actively collect software with policies and agreements in place, they're still struggling with issues pertaining to standards, best practice, and preservation workflows. The legal policy group is focused on legal research and advocacy pertaining to copyright and licensing. So this includes the fair use best practices work that Ewan mentioned earlier that Brandon and Peter are very actively pursuing. This also includes a 1201 exemption. So SPIN has partnered for the last 2 or so years with the Cyber Law Clinic at the Berkman Klein Center for Internet and Society at Harvard. And then in 2018, we're looking to expand to a comparative legal study that looks at similar approaches in 2 different national contexts. The Technological Infrastructure Working Group is starting their data gathering at the consortial level. This is digital preservation consortial level to understand what existing digital infrastructure organizations already have in place to support storage, preservation, access, and sharing of software and metadata associated with software. And then the Communication Working Group and the Governance Working Group are all doing the work to support those other 5 core activity areas. We also have affiliated projects. There are currently 2 already funded and underway that are focusing on areas that we feel are really important with 1 in tow. So those areas would be broadening participation in this work, establishing the fair use best practices for software preservation, and scaling access to emulation. This is a mostly up-to-date list of organizations, projects, and programs represented in SPIN's membership and activities. As you can see, a lot of these are, or if not all of these, are cultural memory institutions of some sort. We do have a couple of different firms, and we have Software Heritage, which is focused on source code, specifically research source code. So we have some variation, and we're working on that representation. So partner with the Software Preservation Network, and let's save software together.
Okay, thank you all for hanging in there. Penultimate presentation, okay? 1 left to go after mine. I am so happy you're hanging in there, though. We've been jamming. Well, Tim is you're doing a wrap-up, right? We're still jamming information down their gullets, right? I think it's interesting. I have to come all the way to Washington, D.C. to meet two fellow Austin Texanites. It happens all the time. I'm actually here as a representative of Building Smart International. Also in my full-time job, which sometimes prevents my work getting done, is with Vectorworks. We're a software vendor. We're based just up the road in Columbia. And I get to see people like Greg Schleusner, Roger Grant, Christine Fallon. There are many of us who are associated with Building Smart, both locally or nationally and internationally, to sort of promote and put into practice some of the ideas I'm going to talk about right here. So hang on. Here we go. All right. So I want to talk about who is Building Smart International, what is IFC, which is one of the standards that we deal with, and why? Why should we worry about IFC? Why should we be concerned about it? So who's Building Smart International? Simple as this. It's an international home of Open Bim. Okay? What do we mean by Open Bim? When we talk about BIM, we talk about building information modeling. When we talk about Open Bim, what we're trying to do is remove that proprietary layer, where we're saying that the data is more important than the tools themselves. And so, as architects, as engineers, as designers, as owners, as operators, we should have access to that information in a way that's completely free of any particular tool, so that we can move it from tool to tool and operate with that information as we need. So as an organization, Building Smart is international, and it's supported by the chapters all over the world. And I believe we're actually up to 18 now. There's, what, 15 showing there. Russia just actually started their own chapter. And most of these chapters are nationally based. The Australasian chapter includes Australia and New Zealand and also Tasmania, a couple others out there. And then the Nordic countries have a Nordic chapter that is also broken down into one for each country. But the idea is that we see a perspective of the building industry across the entire globe. And this is one of the things I want to emphasize in this talk, is dealing with an expanded context. I think a lot of times when we get together in symposiums like this and talks about this, we really sort of hyper-focus on an immediate market or immediate problem. And what we hope to do with Building Smart is to get people to understand that there is a larger context, that this is a problem lots of people face in many parts of the world, if not all parts of the world, crossing multiple languages and cultures and practices. And so that input is necessary in order to create standards that work well for everybody, or at least baselines in which everybody can build upon. And there are a number of people that are involved that belong to this organization to run the organization and promote these ideals and to develop the standards. And the three core programs we work on are things like standards, users, and compliance. By standards, that's developing the things we'll see in the next slide. By users, it's an international user program where we actually engage with practitioners. We have to bring them to the table to A, educate them about what the standards are and why they're useful, and then B, how to use those things, and C, get input back from those people to understand what are the best ways to mature and move those forward. And then finally, there's compliance. Like Phil was talking about with the CAX forum, we have certification of software to be able to exchange this data using IFC, which we'll talk about. We have that certification program that does that. So in the building industry, there are applications that have been certified to be able to exchange information with each other. The challenge is getting end users to understand that and to actually utilize it. And then we're also launching soon a professional certification, which says, hey, I not only understand BIM, but I understand Open Bim at a professional level as an individual, but also as a business level and an organization level. So Building Smart is a conglomeration of companies and organizations that are putting their money where their mouth is. At different levels of support and sponsorship in many different parts of the world, they're saying this matters to us. We see the value of trying to provide standards for the industry across all the different processes. And so we're putting money in order to fund all of the activities that are necessary for this to move forward. And essentially, what do we do? So simple as this. We develop and maintain open international standards for BIM. As I said before, how do we remove that proprietary layer from the exchange of data? And there are three main or three core standards that we really deal with. Information Delivery Manual, which essentially is how do you establish the business case for exchanging data or storing this data, right? Greg was alluding to this earlier about there has to be a business value. That makes sense. So if we can establish what those business values are, then we can begin to build the standards and the technology that then supports all of those values. The industry foundation classes is really the technical part of our standards. And this is this technical specification or the data model for that free exchange. And then there's the International Framework for Dictionaries, or as Roger will talk about, this idea of the Building Smart Data Dictionary, is how do we cross all of these cultural and market and language lines to have common understandings of what building elements are and what materials are, so that when somebody says it in one language, we know immediately through translation what it means in another language. And that's no small thing because we live in a global market now, right? We are in a global industry. We get parts from all other parts of the world. We can have designers from multiple parts of the world working together. So we have to have those layers of understanding. And it's not just about design. This is about the entire life cycle of the building. In effect, a reiterative life cycle of the building in which when you come to decommissioning, the end of the life cycle of a building, if we can gather enough data about that building's performance over its life cycle, that gives us more information to then turn around and do a better job on the next building. Or decide, what do we do with all of those old assets? Can we recycle them? Can we reuse them? If we demo them, where are they going to? We can capture a lot of information throughout the entire life cycle. And Building Smart International, as an international organization, as a standards organization, works through multiple organizations, primarily at the top ISO, right? This all exists internationally because of ISO. But we also work with other national standards organizations. So for example, in a regional sense, we deal with CEN, which deals with all of Europe. But then within CEN, you have things like the British standards and you have the German DIN standards. And when something is accepted at the ISO level, it trickles on down. Now, we also get things from ISO in order to feed the IFC standard, and STEP is one of those. IFC is actually a derivative of STEP. And we use XML, we use X3D. These are all other ISO standards that feed in what we're doing so that we're not really reinventing the wheel. We're using best practices and best standards that are already out there. And in the end, what you really need to understand is building smart are people. So this is a photo that was taken just a couple of weeks ago in London. Greg's in there somewhere. Roger's in there somewhere. Where we all got together and we talk about these issues. We talk about, what are ways to improve the coverage of IFC throughout the built environment? What are the use cases for exchanging data between different stakeholders? What are these projects that we can bring together and make it more useful for people? How do we promote it to the rest of the world? Okay, so as I said, three main standards. The one I really want to talk about today is IFC because in this context of how do we preserve information, this is the one that matters really the most. So IFC, in its essence, is just a description of the built environment that's open, public standard. It's non-proprietary. No vendor owns it, can control it, right? It belongs to the world. It's free to access. And the whole idea is that in that description, it's about geometry and information, not data. As a data scientist once told me, he says, data is for computers, information is for people. It's context, it's semantics. So if I look at an example of a piece of geometry, I can look at it and say, well, what is it? This means nothing. It looks like something, but I could guess. And what IFC does is it has data structures in there that says, okay, well, as geometry, is this a solid or is it a surface? What level of complexity of it is there? What is it? What is it in relationship to how we think of buildings? Is it a column? Is it a duct? Is it a pile? Is it a piece of a wall? right? And then what are the attributes? What are the properties to it? How do I identify it? What are its physical attributes? What is its performance values? And how do we use, or how do we classify it in terms of these other systems when we do the costing or mapping to systems for tracking processes, right? And then what are the relationships? Within IFC, I can determine is something external to the building or internal to the building. Is it being supported by, is it supporting something else? Is it within a particular room? Is it within a particular wall? So then I can say, hey, this particular piece of geometry has all of this data attached to it. It has an understanding of what it is, and I can query it, and I can look at it, and I can get a better sense of what's going on and what it is. But it even stretches out to understand the built environment as we understand the built environment. There's a project level, there's the site level, there's the building level, and then there's all the pieces that become a part of it. And it's not just about objects, but it's also about this idea of controls, of performance history, of processes, of the people that are actually assigned or a part of these objects and these processes. And it's more than just buildings now. We're currently in a phase where we're looking at describing the entire built environment. Infrastructure is now being worked on by multiple countries, describing roads, bridges, railways, tunneling. We're not going to stop at buildings. And this has been going on for some time. It's over 21 years, 31 years. Oh, jeez. So it began with an alliance with Autodesk in trying to determine how do they get data between all of these different permutations of the platform, and it's turned into something greater than that, and it involves a lot of different people and a lot of different applications. IFC can be expressed in multiple ways. We're talking about the step file. But there's also, using computer science best practices, is being able to exchange this information using XML formats. And being able to zip these things up into containers that can be exchanged more efficiently. But the future is looking even better. It's really amazing as we look at what computer science has done over the last 10 to 15 years, how can we apply that to what we're trying to do with our data? When can we get to the point where we're no longer talking about file exchange, but we're simply talking about querying tool to tool and we're streaming data around? Or we're saving all of it somewhere or linked in multiple places, and we're able to bring information together at that point of use and point of need. So we're beginning to follow along what's happening in the greater computing industry to really mature the standard and how we use data. And in the end, it's the best way to communicate building data globally without barriers. There's no other option really out there that gives us that ability of determining semantics and context and description and processes. And we're doing this because the software industry globally is large. I know there's a lot of talk about vendor A. I hear this all the time, right? You can imagine how many of these conferences I go to, and it's all about this. It's all about this. Yet, if I look globally, there are hundreds, over 1,000 different software companies that serve all of their markets very well with many users. And they all have data that needs to work together in order to accomplish the idea of designing, procuring, building, and operating buildings. Because if I work on this as a tool-centric methodology, it requires a lot of work for one vendor to connect to a bunch of different vendors. And instead, what we need to do is we need to turn this model from being tool-centric into being data-centric. Because this is expensive for a developer to do. It's very expensive. So if I move the model from application-centric to content-centric, I may do about the same amount of work to get two applications to talk to each other, but when I get beyond that one-to-one relationship, it becomes more difficult for somebody. And if I'm dealing with many partners that are trying to speak to each other, there's a lot of work that has to be done. And then lots of things are broken as each individual person revises their content or revises their applications. So if we're all working on establishing or supporting a single standard, we all do the same amount of work, and in the end what we're doing is we're doing less work, we're lowering the threshold for more and more people to come in and utilize that data and be valuable to the process, and we're growing a larger ecosystem for the end users, for the market who want this data, who want these tools to do more and more stuff. Because in the end, what happens is if we rely on a tool-centric model, If you invest into a platform and that platform doesn't contain certain functionalities that are necessary for your business process, that means you don't do them. Now, is that acceptable? If you were to say, hey, you can buy a Ford vehicle, but you can't drive on any of the interstates, would that be acceptable? So why do we accept that in the building industry? And owners and designers need to turn around and force us as vendors to say, you need to support this, because our data is more important than your tools are. So the whole point is this is about creating value in the data, that you own the data when it's open format, right? Otherwise, you have to have an explicit agreement with each of your vendors, and if you stop paying the vendors, you stop having access to that data. Every owner should hear that statement and go, is that acceptable? Is that acceptable? If you can't access it 10 years down the road, what was the point of even aggregating all of it in the first place? So you have that ability, it has longevity. And as a standard that we provide, we're also providing this ability of making it extensible. You can keep building on that data over time. We don't have these radical changes in the standard that says, oh, well, not like, you know, Minicad 5, I can't open in Vectorworks 2019. It's almost impossible to do. But with IFC files, with this IFC standard, I can always build tools on top of those old IFC files and access them. So for more information, go to buildingsmart.org. There's a technical site that deals with developers and those who are interested. Contact me. I'd love to tell you more.
Hello. Thank you for the opportunity to be here to share some thoughts, ideas, and some work with you. I'm Roger Grant. I'm Program Director at the National Institute of Building Sciences, or some people know us as NIBS. We are a nonprofit here in Washington, D.C. that was created by the Congress, but we are funded from work we do primarily for federal agencies to help them with their building programs, a whole range of things from how do you respond to earthquakes to how do you manage the information in your buildings. I'm going to talk about that aspect of it. As Jeff said, I'm also involved with Building Smart International. I lead the product room at Building Smart International, and our primary focus is on all the information that really sits outside of models but contributes a lot to the building process. Standards, specifications, procurement information, data or information about all the products that go into buildings. So I'm going to be coming from those two contexts. This is out of the National BIM standard, and since we're at a library, I thought we should have a good definition of BIM. So you can find this at the BIM standard, but it's pretty good for one sentence about what we're trying to do with information across the life cycle and functional and physical characteristics of a building. So, you know, I know we're here to talk about archiving, but I think what Jeff was referencing was how we use standards to organize information, and I'm going to talk about that aspect of it too. I think if we don't have well-organized information, it makes the problem of archiving it and reusing it a lot more difficult. So most of our work is really focused on how do we organize and get value out of information and apply it to solve problems. I'm going to go through a couple slides here real quickly that kind of set it up, and then I'm going to share some use cases of projects we've worked on for agencies where they have been implementing some of these concepts. And so this is, you know, I just want to point out that a model, and IFC gives us a structured way to do this, but the good thing about a model is it consists of objects, and those objects have properties. And once you've identified those things as the key aspect of a building, you can attach a lot of other things to them. You can structure the properties in an organized way. You can put identifiers on them that let you find them in all kinds of other applications. You can embed specifications that say more about it in language that people can understand. You can connect it to external information. So that's the interesting thing. And you know, the model, we spent a lot of time looking at how do you replicate the graphics that were done in all kinds of different systems. but a lot of the value in using models is in the data or the information that gets attached to them. It's not trivial to think about the information itself, and I borrow this from Kimon Onuma, who works with us on a lot of projects, and the idea that, you know, platforms and separating information from the applications is critical, and we're sort of viewed as being behind in the building industry, and I think that's relatively well accepted in our adoption of technology, but we can look to others like telecom and what they've been able to do, and think about how it applies to us. You know, inside owner organizations, there's tons of valuable information, but it's in databases that were created years ago. They have structures that have gotten a little out of whack over time. But it's still there, and a lot of it is good data. And if you can reorganize it, apply some standards to it, you can make it a lot more useful. Key thing is starting by separating the information from the applications, the key information that is valuable to how you run your business. I'm not going to say too much about this, but other than to say, you know, this is a way to be able to preserve information if you have it logically organized. And a lot of it is tabular data. It's data about the things that you're doing. It's nice to represent it with models, and there's some things that you can't do without a model, but a lot of it is about the data. And also, in the case of the government, it's real important to use standards because you can't be proprietary about the tools you request. So if you have an open standard, you can reference that and you can ask for tools that comply with it, and that's really important. There's a lot of, another important thing on that slide was legacy. We're never going to remake every legacy system to follow a standard, but if it's structured well enough that we can map standards to it, then we can share it with all the other processes that are out there that we want to connect to, and then I think we can also have a way to keep track of it over time. We need the information to be usable. That's important, but usable is a lot different in a lot of different contexts. I mean, if I want to say, you know, this is a space, what do I need to know about it? But if I also want to capture the lighting requirements and the air changes and everything in it, we need different kinds of information with it to do that. But without the information, we can't make good decisions. So we really want to figure out how do we organize information in a way that can support the decisions that we need to make and give us the ability to make it useful over time, not just in one sense. And I guess I put this on here because, I don't know, what are we trying to solve? Well, at the end of the day, we're really doing this because we want to make things better and more efficient. I mean, it's fun to talk about computers and how they work, but if we can't lower costs, if we can't use less resources in the environment, it probably doesn't matter all that much. And so the Brits are kind of an interesting study because they have one agency that manages building for the whole government. And they take a macro view of how the building industry supports everything they're doing. And they have set targets. They've got this whole program on level 1, level 2, level 3, BIM. BIM is at the core of it for them to make their processes better. And they've actually, upped their targets on what they think they can do to lower costs, to make their country more productive, to reduce emissions. So, it's just good to keep in mind why we're doing this stuff. I don't have to talk about this because Jeff did a good job of describing the Building Smart standards, but one thing is to get your information organized in a way that it's logical and you can access it. The next thing is to apply standards to it so others can efficiently utilize your information. It's one thing to organize it for yourself, but it's another thing to open it up so others can use it efficiently. So what we've been trying to do is look at how can we apply Building Smart standards in some kind of a process that we could replicate. And we've been experimenting with this on several projects now. Somebody said there's no one solution, and that's really true. And you do have to experiment to find a good solution. But IFC is the best way to document buildings. And there's some connected processes, IDM. It's important to know what you're trying to accomplish, where it fits into the bigger picture. IDM lets you do that by having a process map and defining exchanges of information. And then within the realm of IFC, there's a way to document those exchanges so that they can be captured in software. And that's really important because we don't want to do this stuff with pencil and paper. We want to automate it and digitize it. And we think it's also, we think every exchange should have a specification that says what you're trying to do, who wants the information, who's the sender, who's the receiver, and what is it. There's a dictionary, a data dictionary associated with it that tells you in multiple languages, because this stuff is being used and reused all over the world, what's in that exchange. And then you can put that into applications, and we can do a better job of standardizing these processes. You know, I guess Greg said, what's the business case? Well, I think the business case is we have to invest a little more up front to save a little more on the back end, and that's really in the owner's realm. So I think where a lot of the opportunity comes to push this forward is for owners, and they're the ones who also need to archive these information about these assets. So the first use case I want to talk about is some work we did for Federal Highway. They were trying to say, how can we have a standard for how to get digital models of bridges? You know, every piece of infrastructure in the contract, you deliver a drawing that says the requirements on it. But if we want to move to modeling, we need a way to do that that is standardized, that can be replicated, that's not based on one vendor's software solution. And so they were looking at options. We explored using the IFC, the Building Smart tools, as the foundation for this. We developed an IDM that for the entire bridge construction process, we focused on one of the exchanges designed to construction. We importantly took some real examples and actually modeled them and developed the requirements from real examples. So really it's important to begin at the end and work your way backwards, and that's what this project gave us the ability to do. We were able to develop the process map and the exchange specification. We worked with Georgia Tech, we worked with a specialist in modeling within IFC, and now this project is continuing to move forward. AASHTO is picking up the development of a national standard. They have projects going now in this realm. So, you know, we're talking a lot about documenting buildings, but documenting infrastructure is really important if we're going to add all kinds of services on top of it. And one interesting thing in the infrastructure market, there's 50 owners of our infrastructure assets in this country. There's not 50,000 like there are for buildings, or 500,000 or whatever. So they have some power to consolidate what's going on. And there's a lot happening worldwide in this, so there's a lot they're borrowing from. So in the building realm, we don't have a process map for buildings, but the Building Smart Alliance is working on it. So I just put this in here. I don't have time to talk about it, but we need to be able to know what's the process and what are the exchanges. And inside of a process are these uses, and it's important to also define the uses that you want to you want to have processes to support. So these were identified by Penn State. Put them on this slide. And so this is another project for Defense Health and the Veteran and VA to take space management is very important for them, and equipment management in their facilities. So they need to identify the spaces and what equipment goes into them. This was all in PDF documents. We worked with them with Enuma to convert this to data, take all the information out of the PDFs, put it into databases, and also expose it to their consultants so they could get access to the requirements from a web service. It's all posted on max.gov, and this tool, you can look at it online, helps you to organize that information and parse it out so it can be put into models. It's got an equipment database connected to it as well. I'm kind of giving you a quick overview here because I'm going to run out of time, but we're also working on projects for Department of State. They have an interesting challenge. They have a worldwide portfolio of like over 12,000 assets and missions in multiple countries that speak multiple languages, and they have an ongoing building program, so how do they organize all of that? So we've focused on several of these use cases as a starting point. In particular, space planning is real important to them, and we started to look at how they do space measurement, and there's a number of different ways to measure space, and so you see that when you look at the results in different systems. And there's also a number of different ways you might name things, and all of our organizations over time, you know, we get different names for things, and actually naming is real important as a fundamental starting point, but just having it consistent in a way that you can put it in some place that you can say this is the source of truth, and then you can point the rest of your organization to it and you can start to build on it. So this is really the starting point, And we've gone through this by looking first at, to get space organized, we've gone through this process, look at coordinated, the standards and the guides about the information, look at, now we'll apply industry standards, we'll continue to do that, but first it's get the information organized. It's then develop ways to communicate out to your consultants, so that comes in through execution plans and documents, your contract documents, and those need to be updated. And we also want to move, and Jeff mentioned this, to being able to validate. Having a specification for information lets you automate the validation process. And I think the whole area of design review is one that we need to continue to evolve to move to as much automated design review as we possibly can. Of course, we need to train people, but the end result is we can rationalize what we call things and how we measure things and communicate that and have it work a lot more efficiently. I'm not going to talk about COBE at all, but COBE is an excellent way to, it uses IFC, it's widely used, it's a way to organize information. But I do want to spend a little time just sharing with you about a use case we've worked on for GSA. GSA has been working on BIM for a long time and how to implement it. They've got a lot of guides. They did the first information exchange specification for spatial program validation that's been in use. And we've been recently working with them to move this concept further along. And we've been working on a use case for energy analysis to say, our buildings use energy. We have baseline standards. We have modeling of energy and design, energy usage in design. And then when the building's operated, we have actual energy usage. But all that stuff is relating back to the same systems. And so if we can put together a model to evaluate that, that could be valuable for operating the building. So we did a process model of this. We took an 8-story real building that had lots of systems in it, and we used that as a case study. Then we mapped the ASHRAE 90.1 as the baseline standard, Energy Plus for building, for doing the modeling, and Project Haystack for the controls data. And we mapped all that to IFC. So now there's a specification for how a model needs to be configured to provide there will be for how to provide the data for doing analysis and also for measuring once the building's been put into operation, the meter data. So GSA plans to share the specification for this at some point once the project is completed, and I think it'll be an interesting thing that can be reused. I know I'm virtually out of time, but I'm going to just do a couple more quick things. So that I really talked about. And this idea of having a process is important, and I think this is something that needs to continue to evolve, but how do we define requirements? How do we publish, extend, and implement it in software and then validate it? So, this is what we're basing these projects on. And the other important thing is having a place to archive information that you've produced so it can be accessed by others. And so at NIBS we have the National BIM Standard, which holds the COBE exchange and other exchanges, and these things we're working on for agencies will ultimately end up there so that we can use the reference standards, use national standards, and publish this stuff and make it available for industry to use. And the process that's documented there is really good for how do you develop information exchanges and make those useful. We're kind of at a phase where we're moving out now to implement this in software, so we're going to find out how this works with some of GSA's activities fully, and this is kind of complemented by this guide for owners to help them organize their information, because I think if you don't have it, if you don't ask for it in the right way, you're not going to get it in the right way. And as we heard, if you're not validating it against your requirements, you may not get what you think you're getting. So you need to know how to structure things so you get what you want. So there's a lot of good information out there. There's a lot of progress being made, and it's an interesting area to work in. Thank you.
Okay, great. Well, that's that's not too far over. We still have 10 minutes for questions. So, any questions? I've got a couple if nobody else does yet. Okay, I'll start. Adoption. So, my question is, for both Building Smart and CAX and LOTAR, you guys had tons of logos of who's supporting the initiatives. But it's been described, particularly in the architectural world, that there's a problem with adoption. So what's the difference and challenges between people recognizing, a broad recognition that these things need to happen and investing in them, but then adopting them? What's the, can you talk about that a little bit?
So from the Building Smart perspective, the vendors have worked a lot, especially in the last 5 years, on implementing these standards in the software. Prior to that time, I will admit as chair of the group, that there was a lackluster effort by a lot of the participants. Fortunately, the demands by mainly European governments and European organizations have pushed that further, pushed it to the point where they say you cannot sell your end users in our countries will not be able to provide services to us unless they use software that is interoperable. And so that really lit a fire under a lot of people's backsides. And that provides a business case then that says, then we must support this. The next challenge then, of course, is to get the end users to recognize that that capability is in their software and that they can use it and that we make it easy enough for them to use, which I think we do a pretty good job of. But they need to understand that it's there and they should. Now, yes, Christine, we could do a lot better. But think of it as version 1.0 and, you know, some of us who know our way around this application a little better than others can make it do magical things. But there is the ability to at least do it to a rudimentary level. So.
I wouldn't say that our experience has been that much different than yours. And I think is this thing on? Hello? I think there's been, you know, it's like 90% of the development has been done in the last 5 or 10 years. And before that, it was everything else. I think we were lucky in the mechanical CAD industry because if you look at the market, there's really not that many big users. And I'm just going to pick a system, and I'm going to make up the numbers, but let's say it's Dassault. You know, Dassault's 10 biggest customers probably are 80% of their sales. You know, it's the Airbuses and the Boeings and the Daimlers of the world. But what it took for us was, since we are so concentrated, it was all those big people beating the CAD vendors over the head with a stick. We're trying to get computer-aided manufacturing vendors to implement this capability now. That's really tough because you look at the computer-aided manufacturing and, you know, it's like Joe's machine shop and he has one license of Mastercam and, you know, what's Joe gonna do? What does Mastercam carry, you know? So anyway, that was kind of our experience.
I guess that doesn't really apply to software preservation.
I have a question for Roger.
Okay.
Hi, Roger.
Hi, Christine.
I'm Christine Fallon from Christine Fallon Associates. Product data. Now, in manufacturing, I mean, if you go to aerospace, stuff is sort of custom made for a plane, right? Kind of. But we use a lot of stuff, what we call off-the-shelf products in our buildings, right? And what I'm running into in implementations I'm doing is this kind of great Tower of Babel of product data. You know, what are the properties that what are the appropriate properties for a chiller, and where do I get the properties? And at this point, it's an incredible, stupid manual thing. Is there any movement in getting manufacturers to agree on standard property sets for their products and delivering them in a standard format?
Well, manufacturers have worked to make their information available online, but they haven't structured it in a common way. I think that there is movement in Europe on this subject because there are EU regulations that require manufacturers to report information about their products in a certain way and about aspects of their products. So that's driving in Europe a SEN standard, a common European standard for how product data templates should be made. We're going to adopt that in Building Smart and have it be a Building Smart standard. We're looking at it originating from IFC because that an object has properties, and so all that stuff can be structured. So I think it's going to get here. It's starting more so in Europe, and I think we'll see that because many of the manufacturers are worldwide.
If you haven't figured out the common thread or trend here, it's not always starting in the U.S. And the fact of the matter is, if you look, to be honest, amongst all the software vendors, at least in our industry, most of us make the majority of our money outside of the United States. Simple as that. The United States is a big market, but the majority of our money is made outside the United States. In 2011, it's a $7 trillion building industry from design through production. Only 1.7 trillion of it was generated in the US. 3.5 was China alone. Okay? So again, it's context, right? We have to look at the bigger picture of this. So if significant parts of our global market are pushing this forward, then we adopt it and it moves forward and it becomes a standard everywhere else, whether they like it or not.
We've got time for one, maybe two more questions.
Yeah, so question for Jessica. I confess a lot of what you talked about was total new alien science to me. I hope I'm not alone in that.
Yay!
Maybe I can just ask you to comment on because I'm very familiar with the IFC Open Data Standards questions. So how does that fit into the questions that you're raising? Why would you need to preserve software if we could just preserve the data standards and not?
Sure. So Tim mentioned this earlier in the day. So we're kind of talking about different sets of stakeholders, and we're talking about different tax associated with those different sets of stakeholders. So I think future forward, a standards approach makes perfect sense, right? It's still a complex digital object, so ultimately you are going to have to deal with those layers of mediation that will still come in different versions, even though they can open a file that includes the same underlying standards. So there's that. But the standards is a future forwards approach, while at the same time librarians, archivists, digital preservationists, researchers that are looking at recent history, the last 30, 40, 50 years or so, are still contending with what we do with everything that we already have. So if we look at collecting repositories, we've invested since, the latter part of, since the 80s, I would guess, even earlier maybe. We have things coming in from the 70s. We've already been collecting passively digital objects in proprietary file formats. They're embedded in our collections, and we don't process collections in archival repositories at an item level. We bring them in at an aggregate level, and we describe them at an aggregate level. And so what we're finding is that as researchers come in and they have these use cases for access, we're faced with this issue of how do we've already invested all of this time, expertise, storage resources, to go back to some of Tim's earlier questions around these digital objects, and they take time to process. And then we come to the point of processing them both for identifying their historical and cultural value, what we would call appraisal, as well as providing access to them in a reading room scenario or in sort of a private networked scenario based on something like a university ID. So we're sort of looking at the stuff we already have primarily right now. And then what I would say is the future forward part of what we do, sort of focused in cultural memory broadly defined, which includes higher ed, would be scientific and social scientific reproducibility. And so this is also a standards future forward facing approach, which you have things like the Software Sustainability Institute in the UK that's doing things like helping to create recommendations and standards for how to write better research software. But even then, so you're using some of the same underlying libraries, but you're creating a unique object. Another place that standards sort of plugs into the software preservation network of all of these different organizations that fit into the network in different ways. They have different roles. So some organizations, in fact, NIST has a software, the National Software Reference Library, that's used as a data corpus just based on its hash values, but it is actually a software library. And so you have these known collections of historical software, the Internet Archive, the National Software Reference Library, Yale University Library and Special Collections, the Computer History Museum. And so if we think about the fact that no one institution is ever going to be able to have all the software they need to accommodate the use cases of their end users for the complex digital objects that they have in their collections, we also are having the same conversation around standardization. It's just a different set of stakeholders.
Okay, not to put you guys on the spot, but are you all going to the happy hour?
Oh, yeah.
Okay, so good, because questions are up, so you got to go to Bullfeathers to ask more. I'd like to thank our panel again.
Thank you, Kit.
And now, if you hang on for another minute, have Tim Walsh come up.
Okay, I'll try to keep this to a reasonable length. I'd be remiss not to start with some thank yous. Personally, it's a real honor to be here, giving these remarks to you. I think we all owe a giant thank you to the Library of Congress, the Architect of the Capitol, and the National Gallery of Art for organizing this really amazing event. In particular, I'd like to thank Kit, Kate, Leslie, and Jamie, who's still sitting back there in that solo seat, for doing so much of the work for organizing this. To the planning committee, who put it all together. You know, these things are always, or almost always, sort of secondary things to all the important day-to-day challenges and deadlines and whatever. So it's a lot of work, and they did a really good job of it. And thank you all for being here, to all the panelists too. I'm going to try, more or less off the cuff, although I've been taking notes frantically all day, to just kind of parse back through some of the things that we've heard and sort of try to make some connections, because I think we heard a lot of similar comments and content coming from different perspectives that really reflect all the different stakeholders that we have when we're thinking about the sort of like long-term preservation and access of these very complex, very software dependent, although maybe in the future not quite as much, which is really encouraging, kind of digital objects that we're producing. So if we start with the sort of creators, producers, the architects, the engineers, the people in aerospace and automotive who are actually creating all of these objects to begin with, I think we heard a couple things. One that I think we could all agree with in our respective domains is that standards are not so easy to implement. There's a lot of work being done. You know, the Building Smart initiative is amazing, same with the CAC's Implementer Forum. You see the amount of resources, both people's time, people's money, organizational support by software vendors and institutions that goes into making these standards to begin with, and then they have to get implemented. And like Greg said, you know, these standards need to be market-based, or the motivation for using the standards has to be market-based. This has come up time and time again. I mean, Roger said the same thing, looking at, you know, the British building industry. There's always going to be competing higher priorities than tying everything up very nicely with a bow at the end of a project. So really it has to come back to things like deliverables, like externally imposed requirements. If we, as Greg said, if the standards are not only asked for by clients, by governments, by regulatory agencies, but also tested and verified, then they will happen. I thought a particularly interesting comment from that first session too, a couple things. One, still on standards, Greg's comment that we don't have standards about how you get there, just what ends up being delivered is really fascinating, and I think ties into a lot of the other comments that we've heard about the need for, say, submitting narratives along with files or documenting workflows. This idea that, like, especially in the architectural realm, especially with smaller firms. Every project is going to have its own workflow and its own needs and its own software, unless there's some reason not to, but maybe that's okay. It's just that when it gets ultimately to other architects, to architects at the same firm 20 years later who want to deal with the assets, if it comes to a place like CCA, we have to know a little bit more. We can't just be presented with the files. I think in our experience at CCA, doing the kind of thing that Belmore is doing with Yale is a really great exercise. You know, we've even sometimes, when we get the files in, basically set up a Skype call with the people who actually created them and shared our screen and just walked through the directories and been like, tell me a story about this. You know, the same way you might do an oral history by like showing someone a photo to jog their memory. These kinds of things are really, really important. I think we hear some consistent things about labor and time. That firms often don't have a person dedicated to arranging and describing the data, or that it's sort of like a secondary task at the end. That it tends to be either the architects themselves, sort of all pulling the weight, or technologists who maybe have a different perspective. My plug here would be, if you can afford it, you should hire archivists, because we think about this a lot. But you know, that's not realistic for everyone. And like with collecting institutions, no individual firm or practice is going to solve these things on their own. So all these initiatives that we hear that are very collaborative, I think, are extremely important for moving us forward. You know, things like LOTAR is a great example of basically different, actually competing commercial entities recognizing that they have common problems and cooperating together, demonstrating the business value, and then actually being able to implement standards to drive their costs down, lower the number of mistakes being made, all that sort of thing. And thinking about the creators, also, something that's easy to forget sometimes, I think, for us collecting institutions who are faced by how daunting CAD and BIM and 3D modeling files are, that there's things besides those that we need to be collecting. You know, there's a whole realm of documentation of knowledge about corporate culture, about processes, about events that predated larger cultural contexts, that shine a light into why projects happened as they were, why designs happened as they were. And these things mean that we're going to be receiving, thinking about collecting institutions, not just an IFC model, or not just CAD files in whatever of the, you know, like 300 possible formats they're in or whatever, but also we're going to be receiving things like photo documentation and video and email and increasingly web-based collaborative like note platforms and all kinds of stuff, and we need to be able to address all of that. Which means we can't focus all of our efforts, time, and money on like very selected pies. I think it also comes back to collaboration, why this needs to be a collaborative effort, because there are other people working in those spaces. And you know, the Mellon Foundation funded a really amazing task force on email archiving, sort of a state-of-the-art of where we are with people from a bunch of major research institutions, but also Google and Microsoft. And those sorts of things can really drive us forward. We in the ADE, AEC realm, like, don't need to reinvent the wheel. We can plug into these other communities and like provide our unique perspective and gain from other work that's happening in the field. And I think there's a little bit of kind of careful reflection that we should do around capturing things like, you know, Matthew called it capturing culture, Dennis called it capturing transactions. You know, in the end, often what we're interested in, especially in sort of more like research institutions, is not just the end built product, but how we got there, the theory, the praxis, and for those sorts of things, capturing the cultural elements that come before are especially important. If we sort of move on a little bit to the second panel, researchers and scholars, I loved the quote from Kurt's colleague, show me the uses and I'll begin to understand the value. Unfortunately, I don't remember your colleague's name, Kurt. But that's really great, and I'm really glad that we had that session today who did that. I think those of you who are working with primary, digital primary source materials are really sort of on the vanguard. In some ways, there's not a lot of scholarship out there that tells us how people use these materials, which to me means I would implore you to not just share the end products of your research, not just like publish or exhibit, but to share the process, how you got there. like what your research questions are, whether you were able to actually do what you intended to do or had to change because of the not being able to find collections or not being able to do with collections what you wanted. For those of us who manage these collections and provide the access to them, these are things that we need to know in order to inform our practice and better serve you in the end. Another thing that really struck me is that almost none of the use cases that were presented today dealt with a specific singular project. They differed a lot from how sort of like traditional architectural historiography often gets presented. Instead, it was a lot about large data sets, comparisons, design languages, typologies. I'm wondering if this is because we now have the technology to enable these sorts of researches, if there's something about this present moment, or if this interest is going to continue over time. I suspect it's the latter, but you know, the kinds of work that Andrew's doing are really innovative, could not have been predicted probably 10 or 20 years ago by collecting institutions who are ultimately responsible for a lot of these collections. And I think that's a thing that we need to think about, that maybe we don't need to over-engineer the ways that we provide access or the ways that we describe our collections. Maybe the primary responsibility for us is to securely hold these collections, provide access as we can, and then respond to scholarship and to the actual use, rather than our sort of preconceived notions of how people might want to interact with this material over time. Another thing that really struck me that's a question that I have no beginning of an answer for is I thought there was a really interesting back and forth between sort of Matthew's question of like, can we guess which software created a file by the geometry of the design, versus this idea of fully interoperable data that's not tied to specific software platforms. I think there's probably a lot to unpack there. I don't really know how. I'll leave that to some of you. Yeah. Again, I'd implore you basically tell us as much as you can about what you're doing with this material and what you want to do. We will be bound sometimes by other obligations, by our donor agreements, for instance. It's not so easy to convince donors to give over 3D high-fidelity representations of buildings that could be used to reconstruct it, or basically are like a virtual analog of a building. So there are other sort of factors at play here, but I think we will largely be open to reflecting on our practices and seeing if we actually are able to break with some of our older practices, if we're able to provide freer access, if we're able to better support new research methodologies. A couple things for the collecting institutions, and maybe this is the part where it might be a bit more of a call to action for me, because this is my world a little more. Like I said, let's not start trying to go from A to Z and like over-engineering our access solutions. From what I hear from Matthew, from Andrew, the collections that people need to support scholarship largely are not in our collecting institutions. And to me, that should be our first priority, especially for these sort of like, these first few decades of digital design. Where largely they were incidentally collected by collecting institutions, and you know, won't be there for very long for us to collect, either from people moving on to different projects, retiring, the media degrading. I spend a lot of my days getting data off of old media. It's all well past its reliable lifespan. There is significant data corruption, and even the stuff from 10 years ago, 20 years ago. So that's a real thing. I think it's really, we need to think about these sort of new research methodologies, like I said, machine learning, machine vision, AI. Thinking about that our researchers may not necessarily want individual drawings, they might want data sets, and they might be asking questions that are not interrogating a specific architect or a specific archive, but a specific type of work that stretches across archives and practitioners, and whether we can actually support discoverability to help people find the material, like regardless of its provenance, that meets their research interests is an interesting question to me. One thing Matthew Allen said that really struck me, that a collection of documents in their original order provides a lot of clues. As an archivist, that sort of warmed my heart. I think it's true. That's been my experience too, that with digital material, especially with all of the XREFs that you can break if they're not bound in, all of these things, often it's better to leave these collections as they are, and describe them as best you can and annotate them with other kinds of information rather than going in and trying to restructure them and provide some sort of definitive hierarchical finding aid style view into the material. And that we can maybe let people be a little more hands-on and interactive with digital archives than we could with physical, which is something Matthew brought up as well. That, you know, like Ewan says, if our access tools like Emulation as a Service allow us to basically spawn up a new environment every time that's identical to the original one regardless of what the person came before, can we be a little freer? Do we actually need to impose so many restrictions that we had to largely based around preservation concerns that aren't actually that applicable to a lot of these new kinds of materials, I think is another thing to ponder. Here's my call to action part. I think the biggest thing holding us back as a community in this is not the difficulty, not the size of the challenge, but the size of our capacity. That in the end of the day, before we can do any of the rest of the stuff, we have to have the files. We have to collect them, we have to preserve them. That means that libraries, archives, and museums need basic digital preservation infrastructure, which is easier than it used to be. There's a lot of really maturing software out there, standards, professional communities. But at the end of the day, regardless of how you implement digital preservation, it does mean that you are going to have to dedicate staffing and funding to it, which is, as far as I can see, maybe one of the biggest obstacles to really moving forward as a community. We've been talking about a lot of these issues for 20 years now, and I think we have a pretty good idea of what we need to do at this point. We just need more resources behind it. That's not all our fault, though, because most of us don't have more resources than we used to have, even though we have all these new types of assets to handle. So I think funding institutions, too, should take this into consideration. But ultimately, it's probably going to require a lot of critical evaluation of our services, where we spend our money. Maybe not everyone needs to do it. I think probably no, not everyone needs to do it, and not everyone needs to collect at a large scale. But if you want to, it requires funding and staffing ultimately. I think that said, we don't have to start with the complete solution for these things right off the bat. Things like the NDSA levels of digital preservation are there to guide us. It's best to start at a level where you know what you have, you know that you have backups, you know that you can restore from those backups, and then iterate up from there. There's a lot of education and training out there. I think one of the things that didn't really get addressed today all that much, except maybe obliquely through some questions, is training and staffing around working with these materials in archives, that suddenly, you know, we're expected to have these competencies, that we understand archival, we have archival expertise, we understand the sort of architecture, design, engineering worlds, we understand how to operate this CAD software at least well enough to open up the files and look around and say what they are, and to describe them to other people who probably have more expertise than us in a way that's not invalid. Somehow we have to develop a whole community of people like this, and I think we're getting there, but we can use some critical self-reflection about how we boost that up, how we have training for current staff, how we encourage a new generation of people to come into this. Things like the NDSR residency program are fantastic. Maybe we should think about an NDSR architecture. I think there's a lot of things that we could do as a community there. Just like in aerospace and in the building community, we need to work together. We heard over and over and over again today, no one person or institution will solve everything. We all are coming at this with different expertise, different resources, different use cases, and the more we work together, the more we're going to work through a lot of these issues. And in terms of practice, like I said earlier, we can't really focus only on CAD and BIM and models. We have to take a larger picture approach. We have to think about how we document culture and workflow and process and context, so that we don't just end up with some models that are very extremely preserved in like perfect interoperable file formats, but with no real context for them. I think the last thing I'd say for the collecting institution, for my fellow people from collecting institutions in the room, is it's on us to demonstrate that our business case exists and is viable. We heard this from the other types of stakeholders again today, over and over and over. If you want people to care about your problem, if you want to move forward, you have to demonstrate that it matters, why it matters, and that there's a way forward. And that's on us collectively. For the representatives of software companies in the room, or that might be watching this at YouTube in the future, I think a few considerations from architectural and engineering firms to facility managers to librarians and archivists to governments. We've heard from a lot of people today that they are interested in retaining access to files created in older versions of your software. And maintaining compatibility with old file formats and versions, and ensuring that your software can write files in preservation-friendly, openly documented file formats have real big-world impacts. There's been a lot of movement on that front around BIM and IFC especially, which is fantastic. But it's a thing that we can forget over time. We live in a world now where even Adobe Creative Cloud can't open the earliest Photoshop files, and Microsoft Word can't open up early Word files, and those are much simpler assets. You know, we have to think about these things in terms of business value, clearly, but also in terms of their cultural value and significance. As Ewan demonstrated, there's also quite a lot of us out there who are interested in running older versions of the software in like virtual machines and emulators. Whether it's the software vendors, whether it's software developers who just think, you know, on their own, this is a really interesting topic, whether it's institutions thinking about applying for grants. We could use a whole lot more development around these kinds of tools. What Ewan's been able to do and Klaus has been able to do and other people have been able to do, you know, Rhizome, for instance, applying this in the art world is amazing, but it'll only continue forward with kind of like funding and support. And given the promise, you know, that's something we should all think about. And finally, I think, you know, as a member of the Software Preservation Network myself, I love that Jessica stressed this. We need to acknowledge that software is infrastructure, that it's a tool, that it's a way of interacting with data, but also that it's our cultural heritage. And we need to think about that somehow. It's tough because there's always business interests on the line, and that's completely understandable. But increasingly, as the products of our creative activities, commercial activities, are increasingly software dependent and bound, now more and more online, which only increases these dependencies. I do think that there's a valid argument to be made that there's a sort of cultural element to this, a cultural obligation to this. I'm not the only one. You know, UNESCO has the Persist project that's recognizing the same exact thing on an international level. For the standards organizations in the room, y'all are awesome. Keep doing that work. Pushing for open and documented standards. I found it very interesting that the compatibility and adoption is increasingly there. Also that it's increasingly there because governments largely in Europe are increasingly requiring it, which tells us a lot for the clients and government agencies in the room, how we get things done and how we ease our collective problems. You know, that the power of regulation and deliverables requirements is probably one of the biggest powers in this space for making things happen, came up over and over and over. I'm also really glad that we ended on 2 Building Smart presentations because I think it outlines the kind of bright future that's ahead of us. That, like Jessica said, we're going to have to continue to deal with the old stuff, and that will require all kinds of creative solutions. It will inevitably result in some loss. That's okay. That's the way the world has always worked. But for the path ahead, we can at least try to lay down these standards, encourage their adoption as much as possible. You know, for the collecting institutions in the room, I think a lot of us archivists and librarians have skills in terms of knowledge and information organization and long-term preservation that we're keeping within our professional confines. It might behoove us to think in a slightly more like post-custodial model, like go to conferences that aren't library conferences, go to meetings of architects and designers and engineers and talk about why we organize information the way that we do, and try to make that a back and forth. In general, I think clearly collaborative discussions and efforts are going to be the key in all of this. And I thought I would, you know, we all benefit from standards, we all benefit from openly documented formats, we all benefit from good documentation, you know, from the firms themselves who want to go back and look at materials, to scholars, to collecting institutions. It's really everyone. And I thought I would leave this by just reiterating Roger's comment. We have to invest up front to save in the end, which I think ultimately underscores a lot of what happened here today. A lot of that investment is happening already. It's clear, look at how many people are in this room that are doing amazing work on this problem from so many different angles, coming from so many different stakeholder communities. It's fantastic, but it's up to us to continue the good fight. Thank you.
So thanks, Tim. That was great. It was a wonderful wrap-up of the day, and I really enjoyed your call to action, so I think it gives us a place to move forward. I'd like to give just one more round of applause to all of our speakers today. It's been a long day, but I think it's been a great day. It's hard to absorb all of this stuff when you're sitting in the audience on the first go. So a reminder that this is being taped for YouTube, and we will have a report about the themes of the day coming out in probably early 2018, and we'll distribute those widely. A quick announcement on behalf of Nancy for IPRES 2018 is going to be in Boston, and correct me if I get this wrong, September 24th through 27th, 2018. Okay, great. So be on the lookout for calls for papers for that. Those of you who are participating in our workshop tomorrow, please go to the cafeteria and we'll do a little powwow. The rest of you should go to Bull Feathers and order me a Chardonnay. Okay, so thanks so much for coming, and it's been a great experience, and we hope you have enjoyed it as well.
This has been a presentation of the Library of Congress. Visit us at loc.gov.